when I discuss VXLAN, what are we really discussing about? Now, VXLAN, it is something that is used, number one, in ACI. Like for us, that's the interest, right? So when you ask me about teaching ACI or giving you the understanding of ACI, I immediately said VXLAN is what we have to know. Because under the hood, VXLAN is what happens. Okay. Now, anything and everything I explain with regards to VXLAN, I can do it without ACI, and I can also do it with ACI. So conceptually, it's the same stuff. It's the same thing. So that is where VXLAN itself becomes an interesting point, apart from ACI, because I can use VXLAN just like that, independently. The second advantage and the reason why we need to learn about VXLAN is I can use it for both within the data center and DCI interconnects. I can do that. And it's an open standard. So with all that in place, like every vendor has embraced this VXLAN technology. Okay. Again, my guess, this will be like, it's a little bold statement to give, but it will be like TCP/IP protocol suite. Okay. That's again, it's a little bold statement. Maybe it will happen. Maybe it will take more time. Maybe not. When I say it's going to be like TCP/IP, what I mean by that is when TCP/IP was around, there was this OSI, still very much there. There was this IPX/SPX, which was a novel architecture. There was AppleTalk architecture. And then there is TCP/IP architecture. Like there was competition among these. Which one will win? We were studying IPX. We were studying TCP/IP. Apple was like always a proprietary thing, so we did not have much expectation on that. But definitely there were these two architectures. And finally today, IPX/SPX is like what? Who cares, right? Nobody bothers. So in the future, when you talk about LAN communication, this is what I think everybody will speak about. Okay. Today, when we talk, like we are all old people, I'm assuming. We say that frames are sent, and what will the frame contain? A packet. What will a packet contain? A segment. What will a segment contain? Data stream. Like that's networking for us. So in the future, people will say, what is there in the Ethernet frame? You're still going to send Ethernet frames. Okay. And maybe if Trill comes, you may send the Ethernet frames in a different format. But you are going to send the Ethernet frames. What will be there in the Ethernet frame? Packet. In the Ethernet frame, what will be there? Packet. Okay, in the packet, what will be there? Ethernet frame. In Ethernet frame, what will be there? Packet. And in the packet, what will be there? Segment. And in the segment, what will be there? Data stream. Right in the middle, somewhere here, somewhere between this packet and this frame, you will have whatever is called VXLAN header. So this kind of becomes the norm for the future, I think. Okay, people when they hear like 10 years from now, they hear that the Ethernet frame contained a packet and then the segment. No, that is all will be there inside. No? I don't think that will be there out. So that is what people will think. Again, I gave a little too much of unnecessary stuff. Unnecessary in the sense, maybe at this point it's not understood well. But we will have to understand how the VXLAN works A to Z. So once I make you understand that, then you understand what I mean by this whole stuff here. Okay. So with that said, let us talk about VXLAN. Before I even talk about VXLAN, we had a shift in the way we look at our networks. Okay, that's the first thing we will have to keep understanding. The shift in our network is, okay, what is the typical network architecture in a data center or in an enterprise? What is a typical network architecture for us? The typical network architecture we had was always the 3-tier architecture: core, distribution, and then the access. We always had this kind of a network architecture, always, right? And if you look at any documentations that came from Cisco until the last 10 years, I would say, this is the best architecture in the world. We recommend this. We always deploy this. This was the slogan. The purpose of the 3-tier architecture is what? Why do I need this 3-tier architecture? What is the need of it? The purpose of this 3-tier architecture is to divide the functionality. They wanted to divide the functions. If I just wanted redundancy, I can simply have 2 mega switches and, and all the systems will be connected to these 2 mega switches. I can get redundancy, right? If redundancy is my goal. But that's not just the function of your network. That's not just the requirement of your network. There are a lot of functionalities that are required. So they had this architecture saying, okay, in the bottom access layer, you connect your devices. This is where you connect your access devices, end devices, servers if it is a data center, client systems if it is a enterprise network, right? You connect your systems here. And right here at the first hop, provide a couple of things. Provide the basic security, the port security, how many MACs you should allow, how much offloading is allowed, how much how much offloading is allowed, and any malicious attacks like DHCP attacks or whatever, you'll have to provide the basic security here. Okay, because the moment you hit this network, the switch, and get out of it, you're not just interrupting the switch, but you're interrupting the entire network. So for that reason, the basic security is provided. And then another important function, quality of service marking. And we discussed this in QoS. So we do that here. When it comes to the distribution layer, the major function of distribution layer is L2, L3 boundary. That is, and even today, that is how the distribution layers are built. What do you mean by layer 2, layer 3 boundary? This is where you basically have your gateways. And the other functionality you had was the PBR, policy-based routing. Typically, this happens via your IGP processes. Mostly OSPF, I believe, but it could be any other process. So this is where you decide, okay, I have multiple connections to go out. Which one is better, R1 or ARC? I do my policy-based routing here. Okay, and this is where typically you will have one of 2 options. Either you will configure this as routed ports and do typical routing, or you may have trunk ports and do SPI to router interfaces, sub-interfaces mostly. So one of those 2 things you will do, and you will have PBRs. And at the core, there are 2 major functionalities. One is quality of service implementation you can do here. And the other thing which you can do here is switching. Okay. It's a very bad thing. I want to say fast switching, but technically fast switching is actually slow switching. But here you want to switch as soon as possible. Reduce the overhead. Reduce the overhead of processing the packet. The moment it comes, I should know where to send and get it out. Just send it out. That's what here we should be doing. And there is also PPR done here. Typically with regards to BGP, we do it. Again, no strict rules, but typically we do that. Okay. And on the distribution, it's worth mentioning, I may also have gateway here, of course, and the PPRs here, of course, and I may also have these other services. Okay, the services could be like load balancers, it could be your firewalls, so whatever service you have. Okay, so maybe you wanted to hit the servers, if it is a data center, through the load balancer or through the firewall. Maybe if it's an enterprise, I don't know. Maybe you may not need a load balancer, but you may definitely need a firewall. So this is how it works. The purpose of this 3-tier architecture is for this functionality split. If I give all these functions to a single or a pair of boxes, that's a lot of overhead for every packet. Okay. So what's wrong with this? What's wrong with this? Why? Why do I have to change it today? Functionality did not change. As a matter of fact, they became more efficient because silicon was better, right? As a matter of fact, if you talk from 15, 20 years back to now, definitely, multiple functions can be done by a single box. Before it was not possible because of the ASIC capacities. Now they have exponentially increased. Okay. So what changed? What changed that I had to think about this as a problem? The two problems we had with this architecture was, the two major problems we had was, number one, we had this access to the distribution using only single links. They were using only single links. STP was coming in and kicking in and blocking all the ports except one port. That was the problem we had. The second problem we had was the gateway choking point. The gateway was getting choked. Okay. Now, I don't find a problem here with the gateway choking point. I don't find a problem. Yes, using a single link, yes, definitely it looks like a problem for me. But gateway choking, I don't see it as a problem. Let me explain why I'm not seeing it as a problem. See, if these are all the clients or whatever you have servers, in the data center it's servers. Your traffic, if somebody in the WAN is trying to access your resources, the traffic has to go this way, right? It has to always go this way. This is called northbound. Typically you have your clients, and this is the southbound. Typically you have your servers. So there was this north to south traffic pattern, and everybody has to go that side because your requests are coming from the WAN, internet or intranet, doesn't matter. So you're in the path, like this gateway is in the path. You can't avoid it, right? You just have to go anyway. So I don't see that as a problem. Gateway choking. But here is what happened. Here is the real reason for the change requirement, the demand for change. The demand for change came because applications have become weird. For us, applications have become very weird. Now, what is happening is east to west traffic. I'm always embarrassed with which is east, which is west. I'm making a guess. This is west, this is east, I think. If I'm right, I think I'm right. I don't know. But the point is this: east-west traffic is basically server to server traffic. South is again server, clients are on the northbound. The problem is nowadays everything east-west traffic, every application, the east-west traffic is growing. Okay, there was one statistic saying that about 66% is east-west traffic. But again, I'm a network guy. What is east-west traffic? Server talking. What do you mean by that? I did not understand. Okay, server client. Okay, I understood that kind of. But what is this server traffic? Why will that be? What do you mean by applications have changed? What exactly do you mean? Take a very simple example. Okay. I don't know. We used to use Yahoo Messengers. Okay, I don't know how many of you were using it. I think you're not that young. Okay, maybe you're young, but I don't know. Internet, we used to get 1 hour internet access for 100 rupees, 120 rupees. How many of you have experienced that internet experience? Anybody experienced it?
Yeah, Kalyan, I have. Initially, actually, we used to go to the cyber cafe for 50 rupees and we used to chat.
Yes. Yeah. And then if you have an internet center, I mean, you can get married. You're settled.
We go to the chat rooms and search for girls for the chat for America, Australia, go outside.
Exactly. Yes. So that was the time, right? That was the time. Things were very, very, very simple. Okay. And we used to see boards, 128 kbps high speed bandwidth. Okay. That time ISDN was the technology actually. Okay. So 128 kbps high speed bandwidth. Come on. Okay. So we used to have those things. That time it was very simple. There were these web servers providing some mail services, providing some chat services. It was all new. We used to open these web pages, and there used to be this place where we get a flash image. Like it would take about 5 seconds to bring the flash image, but still we are very happy. Wow, there was a star there. There was that thing there. No, it was very plain simple. People used to go to the web servers, get the web pages. People used to go to their mail servers, send the mails and receive the mails. They used to go to the chat server, just get it done. It was very simple, straightforward stuff. Applications were simple. Now you have the beasts. Okay. You just go to this website. It's a hypothetical example. Okay. Don't take my word for granted. It's just a hypothetical example. If there is any coincidence, if there is any relation to the reality, it is just a coincidence. Like in movies, we say, right? It is all fictitious, but if you see a resemblance, it's just a coincidence. Okay. So we have this website. I don't know the name of it. Maybe it is abc.com. All that you wanted to do is just log into that website. Your request will come to the www, the web server. Once it comes to the web server, it will take your username and password, go to the authentication server. It will go to the authentication server and the authentication is done. Yes, this person's right username and password are correct. And then what it does is the web server goes to the user database server, pick the right corresponding username, corresponding folder basically. And within that, this particular folder contains all the list of their friends, all the posts that they have made. I am brushing my teeth. I just woke up. I'm just having a cup of tea facing north. whatever shitty stuff, I'm sorry, whatever stuff they wanted to post, they'll just have those posts. So it has to go and get all the posts, but I cannot put all the posts here. So I go to the posts database and user database. I get the users friend list, users applications list, all of that will come here. And based on that, I will now go again to the post server, and from there I take all the posts this guy has posted or the girl has posted, whoever, and then it comes back with all the posts. It's not over. It's not over. And you're here waiting. You just made a request. Okay. Now what happens is, okay, it will go and look at the database of all the friends that you have. And the current status of their friends is all what it takes. It collects all the information about the status of their friends and their posts. It's not over. When you made a request, you have sent cookies. And within the cookies, not only that your request will come, but also what you were browsing, I don't know, in the last 1 day, 1 hour, 1 week, 1 month, I don't know. It will look at those cookies and identify, oh, this person is actually searching for a mobile phone in the last 1 week. They are searching for a mattress or whatever, they are searching for it. And so I will go to the advertisement server, collect the relevant advertisements from the records of the cookies we have, and advertisements will come here. All of that will be sent to you in response. Ooh, I don't know what this website is. Sounds crazy, that much I can say. Okay. See, you made one request. Previously, it wasn't this complicated. Make a request, there's a web page, link for that, and that web page will come from the web server. Over, job done. You go to the centralized chat server, there you have all the chat messages going in. There is one application running on that one server. Maybe if load balancing must have been done, but that's okay. But end of the day, that's going to one server, and then all that I'm doing is putting my messages in and out of that server. So it is the application's responsibility to categorize them. Okay, this is this guy's chat. I have to keep a separate session for that. So it was very simple. Now it is not. And the job is not over, right? As long as you're connected to this, anytime you press a refresh, anytime you do whatever, it has to reflect again going through all this process. Okay, that's a lot of east to west traffic. I hope now you understand what that east to west traffic really means. Now, from a networking perspective, we are very innocent people. We don't know all of this stuff, right? From a networking perspective, they will say, my application has got 20 tiers. I don't know how many they will have, but 20 tier application it is. It has a lot of servers and etc. etc. You don't care about it. You don't even know. You don't even ask them what is the application's logic. That's none of our business. We simply say, okay, whatever you say, how many VLANs do you, how many networks do you tell me that. Okay, I'll open my Excel sheet, whichever network is available, take it. How many hosts are required for each of the networks? Tell me that. Well, my application server will be like 4, I think. No, don't call it application server. Tell me how many servers you. I don't care what you run there. Our mentality, our mindset, our way of thinking is completely different. We don't care about application. Right. So each of these groups, like the user database, authentication server, the post database, or the advertisement server, or whatever I have there, all of these are different tiers of an application. They talk to each other. in a particular programmatic way, whatever the business logic is. Okay. So now the gateway choking point becomes a real problem. Real problem. See, the gateway is going to be in one place, right? For one network, it is going to be in one place. So now if there is a 2.5 trying to communicate to 3.7, this is one type of server, that is another type of server. I have to not only go to the gateway, but I'll also have to come back. Couple of problems, and I mean both the problems. Those are the couple of problems I'm talking about. One, my gateway is choked because every time anybody from 2.x wants to talk, they have to go there. I didn't have a problem when the traffic was going just out. Okay, because physically you're anyway there. So you have to process it anyways. But the problem now was I go there and again I come back, which is a choking for my gateway, and I need double the bandwidth here now. Right. Now my 1 gig is not sufficient because now I need to take into account the return traffic as well. I go there, come back, go there, come back. So bandwidth here is, the demand for bandwidth is more now. Okay. So now my thinking changes. So you now exactly know why the thinking changed. It's not our problem really. It was the application's demand that felt like a problem for us, and which is definitely a problem for us. Okay. So with all this said, what can we do? What can we do? Now, right away, I don't want to get into VXLAN, okay? We did few things. We tried our best to manage with few things. You have your core, you have your distribution, and then you have your access. We had all of this stuff. The first thing we did was ether channels. Everything we discussed. We created ether channels. Okay, you want more bandwidth, so we create ether channels. Even though you created the ether channels, yes, I was able to get more bandwidth, and if I use LACP-like protocol, I can actually have 16 links, out of which 8 can be used. So even though one link goes down, I will still not compromise on the bandwidth. I can still have 8 in any given point. So I was able to do this, but a couple of problems. So number one, still I need device redundancy. No, if that switch goes down, then what? And then still I needed STP. I just can't avoid STP, right? So what if the loop is found within these port channels? So I needed that. So this is where we said, okay, fine. Don't waste. Two problems I said. Right? Number one is the bandwidth if something goes wrong, and the device redundancy I said. STP you cannot avoid. And the third thing also I wanted to say, that is port wastage. Like you're wasting certain ports, right? If you connected 8 ports here, then you're keeping another 8 ports just for the backup purposes. Okay, so port density also you're losing. Okay, so then we came up with the other idea of VPC. VSS was there. Okay, so that, okay, instead of wasting 8 ports, one set of 8 ports is totally wasted. Instead of that, I can connect 4 here, 4 here. So I still can get 8. So parallelly, I can use them. At the same time, I will get device redundancy as well. Okay, so that's the key factor for me, right? So yes, I used this VPC technology. Again, all of these, we are trying to have them as solutions for this bandwidth requirement. Single links instead of having just a single link. But even with VPC, the problem is that I can have only 2 connections. So I cannot have an arbitrary connection. I cannot have arbitrary connection like this. Maybe I have another switch. I cannot just connect 4 devices and I cannot make it work. But Cisco came up with a solution called Fabric Path, which can allow you to do that, which was the starting of things. So it was fine. It was nice. Okay. But that was Cisco proprietary. So that is the way we came up with. We came up with for VLAN STP first, then we came up with Ether channels, and then we came up with the multi-chassis Ethernet. And Fabric Path did come because we talked about it, we know about it. Yes, it is there, but it's Cisco proprietary. We have a proprietary lock on that. Okay. Second, how about the gateway choking? When it comes to the gateway choking, yes, I can run multiple protocols like HSR. Yes, I can do that. Okay. But even if you take HSRP, for example, per group, I can only have one gateway. On a per group basis, I can have just one gateway. Okay. So it wasn't a problem solved. Right. At least, multiple gateways were there because I can create multiple groups instead of 10.1, 20.1, everything sitting here as active gateways. I can have 10.1 here, 20.1 here, 30.1 here, 40.1 here. Yeah, I can do that. But the moment I do this, the traffic may go on a suboptimal path. So for example, 30.1 is there. And if I wanted to communicate from 10.5 to maybe, I don't know, 30.7 or something, the packet has to go to my gateway first. And from there, it has to go to the other side gateways. And from there, it has to go to the 30.7. Okay, again, I'm loosely giving this analogy. So you have to go and start using more and more of this link. So at that point, even having Fabric Path will be a little congested for me. So yeah, the first thing we did was we tried to have HSRP with multiple groups. Again, when we say HSRP, it is typically VRRP because it's open standard. But we were able to use that with multiple groups. Again, single choking point on a per network basis. So then we went with this idea of VPC. All right, instead of that, what we can do is we can have a VPC. By configuring a VPC, what happened was 10.1, even though one was theoretically active, we were able to use them simultaneously, right? So now there were two gateways, like truly sharing the load. So if I had a VPC, a packet coming here, this device will respond. And if the packet goes here, that device will respond. They don't have to go to just one place. Okay. It was good with VPC active gateways. I was able to load balance. Okay. But still remember, you will have multiple VPC domains, right? This is 2 switches in one VPC. There's another 2 switches in another VPC. So this is VPC domain 1 or whatever, VPC domain 2, VPC domain 3. There can be only one VPC domain that is a gateway, right? There's only one that can be a gateway now. So if there are systems connected to this set, and if they want to go to the gateway, then again I have to go and use this link, the distribution to the access. And again I have a round trip to make. Not good enough. And always keep in mind, 66% of the traffic going is east-west. There's a lot of traffic here. Lot of bandwidth consumption happening there. Okay. So, yeah, we tried our best to do these things. Both from the perspective of getting more link capacity and avoiding the gateway choking. Not good enough. Take a very, very simple challenge. If 20.5 wants to communicate to 10.5, can I go and communicate without using my distribution layer links? Can I do that? No, I can't do it. No matter what, I'll have to go somewhere to the gateway because my gateways are in the distribution layer. I have to go and then I have to come back, whatever technology I'm using, including fabric path. I have to go and come back again. Choking on that gateway never stops. So, what should I do? This is where they introduced the concept of, wait a minute, let us start thinking completely differently. Instead of having a 3-tier architecture, why don't we have a 2-tier architecture? Obviously, if you keep increasing the number of layers in the architecture, there is a lot of delay. So that does not make any sense. So you have to reduce them. So they said, okay, we will go with a 2-tier architecture. And this is how we will physically connect. First, this is how we will physically connect. We will call this as the spine and this as the leaf. We call this as leaf and spine architectures. See, ultimately, when I complete discussing this whole thing, like spine leaf, VXLAN, when I complete discussing this, I should convince you without doubt that these two problems are solved. I have to convince you by telling you the facts, how the problem is solved. Okay, so that's my final observation. That's the final goal for me. Okay, so the first thing they said was, okay, instead of 3 tiers, we'll have 2 tiers. We call that spine and leaf. Okay, immediately the question comes, okay, then where is my router? Where is my WAN connection? That's the very first thing that comes into my mind. If I have 2 tiers, where will I put my router? Generally, we were so used to this architecture for a very long time. We are so tempted to put the router right there. No. Connect it here. This is your WAN. What? For me, it looks like this is an access layer device. Like leaf is kind of access layer. That's what I'm thinking. So you want me to connect my router there? Like this is a mega router, which is connecting to my entire internet. My data centers are all connected. My big data center is getting connected to the internet. My private data centers are connecting. My enterprise is connecting. So you want me to connect it to this access layer switch? Like, yeah, you may call it as a leaf, but do you want me to connect it there? And the answer is yes. That's where you want to connect. Okay. And the real reason which we don't appreciate, we don't even talk about, is this is possible today only because of the ASIC. The silicon capacity has increased. Once upon a time, when we say access layer switch, low-end model, right? That's the mindset. That's what we used it for. Because the heavy work, now we know very clearly that the heavy work has to be done by the distribution and the core. Because that's where the major services are, major functions are. So we did not need a bulky device. But now we say that this leaf is the one that is going to connect the router. Obviously, the capacity of that leaf should be there. It must be good enough to handle the data traffic going in and out of the band. Okay, so something which we don't even appreciate. because the silicon is now capable of doing it, we were able to connect it there. Okay. All right. Now, I will tell you. Can I connect anything to the spine like my old architecture? Can I do that? Yes, you can do that. Okay. There are certain networks which will do that. Yes, we can do that. This will mimic our 3-tier architecture. Okay. And if you do that, like you connect the spine to the routers upstream and then to the WAN, we don't call it core. Now we start calling this as super spine. Some crazy names they'll give. We simply call it as a super spine. Okay. This is possible. Okay. We can do that. Later, why later? Now only I will tell you. If you are learning ACI, I mean, that's the whole point, right? We wanted to relate this technology to the ACI. So if you do ACI, initially, like way in the beginning, and even today, in majority of deployments, you cannot, like initially, when ACI came, you cannot connect anything to the spine. You just cannot connect anything to the spine switches. Like, not possible. Not at all possible. But later there were certain requirements. Okay, we call them as multi-pod, multi-site. What if you have one ACI fabric on one data center, another ACI fabric in another data center? How do you want them to be extended? Okay, so we have different technologies for that. We call them exact. Multi-pod is there, multi-site is there. Nowadays, in the last 1.5 years, we have things called remote leaf. Okay, so there are different technologies. I mean, there are different requirements. So for those reasons, only for those reasons, you are given an option to connect spines to the routers. Okay, but otherwise, as a general rule of thumb, when it comes to ACI, you just don't connect anything to the spines. You just don't. Okay. But if it is just any other technology, just VXLAN without ACI or anything, yeah, absolutely. You can connect it and then you call it as a super spine. Okay. So I gave you both the choices. Okay. Again, said that it is not a necessity. That's important. It is not a necessity, and as a good practice, connect the routers to the leaf itself. Previously, that was not the case. It was a necessity that you have to connect it to the core from the distribution and then to the routers. Okay. So this architecture, sometimes you may hear the word clause architecture. This architecture, spine and leaf, is also called as clause architecture. Clause is not some expansion. This guy's name is Charles Clause. Okay. He mathematically told the best way to have deterministic traffic flow is this architecture. 2-tier. All the leaves connect to all the spines. All the spines connect to all the leaves. And do not connect spine to spine. Do not connect leaf to leaf. Do not connect spine to spine and do not connect leaf. That is the true clause architecture. Now, you know when this is developed? This was developed for telephone companies. This is not a new thing. This was developed for telephone companies when they were having, if you want to make a call, right? It was even we were not present. When you have to make a call, I mean, trunk calls I was there, but before that, you call the provider, like you call the telephone company, and the telephone company will give you a time on so and so time. I will connect your call, and then they will manually connect. Like literally, they will manually connect it. So they used to have these big network rooms with all the muxes. So they used to connect. So they wanted to find the best way of quickly connecting anybody to anybody. Anybody, any end telephone to any other end telephone. They wanted to have a very quick way of connecting. So for that, they developed this. I mean, it was proven mathematically that this is the best way of connecting. Easy, deterministic, and very quick. So it was that old architecture. Your network was not even existing. It was just telephones. So they brought that into the data centers now. So what do you mean by deterministic again? See, from any node to any node, even LAN, WAN, east, west, does not matter. From any node to any node, physically, you just have 2 hops away. You go to spine and then from the spine to the leaf. Anywhere to anywhere when you connect. No matter what the failure scenario is. No matter what the failure scenario is. One exception, of course, don't expect magic show. If all the links go down here or if that particular spine goes down, again, all the links go down. So that's a very bad state, right? No magic shows. But other than that, any other failures, 1 link went down, 2 links went down, 5 links went down, no problem. As long as there is 1 link to the fabric, the same traffic pattern is what you will get. Exactly the same traffic pattern you get. All the spines go down, still 1 spine is there, same traffic pattern. 2 physical hops away. Logically, Cisco and other documentations will say 1 hop. Logically, 1 hop they will say from this leaf to that leaf. Okay, so from any leaf to any leaf, 1 hop, logically they will say. But physically, it's 2 hops. Okay, so this is what they defined. First, let us have an architectural shift. Don't have 3-tier, let us have just 2-tier architecture.
Means each leaf has to be connected.
Give me 2 minutes.
Okay.
2 minutes. Okay. So here, okay, can I? Okay, I understand your deterministic nature, but can I connect like a spine to spine? I mean, I just want to connect. Can I connect leaf to leaf? Yes, you can connect. Technically, yes, you can connect. In that case, if this system wants to communicate to this system here, I can go quickly. But when this link goes down, then I will use the alternate path. Yes, I can do that, but deterministic nature is gone. Sometime you may get a 5 millisecond, 10 millisecond, 20 millisecond delay, and the next time you may get a 50 millisecond delay. Because when it is this, I will have direct connection. Okay. So I can have it like that, but a true clause architecture says don't connect like that. Now, because I am relating this architecture to ACI, here is another difference. If you are running ACI, even today, you cannot connect leaf to leaf. You cannot connect spine to spine. Without ACI, if I'm just using VXLAN, no problem. Yeah, you can connect the way you want. It's your choice. It's your decision. But if you wanted to use ACI, no, you can't connect. The moment you connect a leaf to leaf, that port will be shut down, like administratively down, disabled. Okay, internally there is a protocol called MCP, a very non-creative name. Miscabling protocol, they call it. So it will detect if a spine and spine are connected, if a leaf and leaf are connected, and it will block. Again, whenever there is a difference from ACI to the general architecture, I am highlighting them. Okay. So in ACI, you can't connect. In ACI, you have to follow a true clause architecture. Yes, please. Question.
Yeah, I got my answer because as you are telling that in ACI we cannot connect with each other. So then it means we cannot. What I was going to ask that if I am connecting leaf to leaf with each other and connecting with any of his spine and not with other spine to any individual leaf. So in that case, what will be happen? But I got my answer. But as you are telling that in ACI, there is no possibility to connect it to each other.
Yes. Okay.
So, Kalyan, dedicated ACI image are there actually. So, means to enable the ACI, we have to upload or run that dedicated image so that ACI can work.
Yes. And those details I will introduce once I complete the VXLAN discussion.
Okay. See, my doubt is means we can enable the VXLAN as well without ACI image.
Exactly. Absolutely right.
So that in that condition we can connect spine to spine and leaf to leaf.
Yes.
And only MCP will get automatically enabled or enabled once we install the ACI image to the Nexus switches.
Yes, if you let the ACI mode work, in that case, all of these extra conditions are applied. Okay, one condition I already told you. You cannot connect anything to the spine. There are some corner cases in ACI, but other than that, you cannot connect. Now the second condition I'm telling, if you are running ACI, you cannot connect leaf to leaf or spine to spine. Both the conditions are not going to be there if I'm just using VXLAN without ACI mode.
Okay, but again means if I'm not, if we have not means upload or ACI image in the switches, if we haven't uploaded, then how VXLAN would work? There is a little confusion in that. Could you please help me out?
No, I cannot. Okay. I cannot in one line. That's the point. Okay. Today, just adding to what you said. Once upon a time, Nexus 9K was the only supporting VXLAN and ACI. Okay, that's the only box. Okay, the hardware, software specs I will discuss in the ACI discussion. But last 3-4 years even the 7K support VXLAN now. Okay. So what I mean by that is, I don't even need a 9K. All 7K devices with the respective software upgrade, I can just run VXLAN. So now the question is even more important to you, right? Okay, how will it happen? Okay.
Yeah, means as per my understanding now, we have to configure step by step VXLAN.
Exactly. So what all those
and
steps?
my last query. Yeah. I think you will come on that.
Yes.
Okay. No problem. My last query is, Kalyan, the way we have connected a router means we can say now core is gone. Our L3 WAN device would be connected on the leaves only. And if we need to connect a L2 switches like our Ethernet switch apart from Nexus, can we do that if required?
Yes, you can do it. Okay. And as a matter of fact, today, it's not today anymore, but yeah, you can say, even today, lot of networks are brownfield deployments, right? You already have your 7Ks, you have your 6500s, whatever you already have. and now you wanted that to be launched to the fabric, like you wanted to connect the ACI now. All of a sudden, every switch you don't stop, and then you don't do a greenfield deployment. So you will very likely see in your environments that this sleeve is connecting to your 5K, to your 7K, to even as simple as a 3560 switch. And then you have your already existing LAN. You can add that. And most of the time you will see that there. Eventually, you want to put all your servers or your enterprise into the fabric. But initially, you can expect networks to have this kind of a setup. And absolutely no problems with that. The problem, the limitation is, keep it in mind, can I run VXLAN technology here? No, I can't run. Okay. My VXLAN cannot run on these because these devices may not be capable. Most of the time they are not. So my VXLAN, the wonderful factors, the wow factors, they are all in the fabric only. Here I can do all of that stuff. So that will be your limitation. But apart from that, yeah, connecting, yes, I can connect. And that's what you will see most of the time in today's migrations.
Down the line means classical Ethernet switching would be there only. And we can use VXLAN and ACI above the leaves.
Yeah, exactly.
Between the spine and leaves.
Yes.
And will you come on that EPIC as well?
Yeah, of course. So that's what. ACI, I will discuss. That I wanted to spend about half an hour at least on that. ACI, I will be discussing as a separately.
Sure. Thank you, Kalyan.
All right. Okay. So all that I have right now is a change in the physical connection. That's all I have. Okay, I connected. How do I solve these problems? I did not talk anything about it. Finally, this is what should be there, right? Finally, this is the goal. I should know, I should be convinced that, yeah, no problem with the bandwidth, and at the same time, no choking point for the game. That's my problem. That's the problem I have to solve. Because you simply put two layers, and because you said that leaf, we don't connect, spine, we don't connect, how will the problems be solved? And to answer that question, we need to understand the underlying technology that we want to use, and that is VXLAN. That is VXLAN. Okay, so we need to now understand and explore what this VXLAN is all about. Now, I am lucky that I don't have to explain you anything specially about VXLAN, like from a data path perspective, data flow perspective. The reason why I don't have to explain too much is because we already discussed the fabric path, we already discussed OT. Because we discussed the data flows there, when we are actually discussing VXLAN, which we are going to do now, you will understand very, very easy. Very easy, super simple. And again, because we talked fabric path and because we talked OT. Let me explain what I mean by that. In order to understand the VXLAN technology itself, you need to first understand the frame format of VXLAN. Now, normally, you must have observed, now I never talked about TCP packet formats. I never talked about IP packet formats. Yeah, I needed some information for LAN communication. I needed the source MAC, destination MAC. So I discussed. Yes, I need source IP, destination IP in the packet. So I discussed. Yes, I need COS bits for quality of service in a frame. So I discussed. Same thing, I needed a TOS bit. So I discussed. So whenever we have any relevance, Whenever we want to manipulate anything, those control bits we were talking. We were never talking about there is a preamble, there is a start-off frame, there is blah, blah, blah. We did not talk about it. But when it comes to VXLAN, we need to know the format of it. We need to know what the VXLAN really does. First of all, before I get overwhelmed with VXLAN is extendable VLAN. Okay, that's what VXLAN is. So I told you the full form. Okay, fine. Right. So many people say VXLAN is a 24-bit VNID, just like a VLAN ID. The VXLAN will also have an identifier, which is used to separate the quote-unquote broadcast domain. Okay, it is also used to separate quote-unquote broadcast domain. More discussion on that later. Okay, that's the unique speciality of VXLAN. More on that later. But right now, just keep it in mind. VXLAN, like a VLAN, has an identifier. VLAN is 12 bits. VXLAN is 24 bits. Because it is 24 bits, you can get 16 billion identifiers. Now, because it is 16 million identifiers used for defining quote-unquote broadcast domain, I can have more broadcast domains. Okay. Now, just keep this point in mind. I will come back to this later. Okay. The reason why I told it right now here is many people think, okay, VXLAN is like a VLAN ID. It will have 24 bits. So it is just another tagging mechanism, just like a .12 VLAN tag, which you simply add a VLAN number. This is also, okay, add a VXLAN tag. That's what some people think. But that is not right. So just to highlight that point, I just introduced this ID. What VXLAN really is a complete encapsulation of its own. You have your original Ethernet frame, to which you will add a VXLAN header. Now, this VXLAN header contains VNID, more on that later, and it will have what is called as security group tag. More on that later. So you have a VNID and the security group tag. This is what you will have in the VXLAN header. Now that whole thing is then encapsulated into a outer IP packet, which will have the source IP, destination IP. Oh, what will that be? Oh, I'm sorry. What a bad thing I did. What a bad thing I did. No. Security group tag. Yes. So this part is encapsulated into UDP. First, I should say that. It is encapsulated into UDP. Like first time when I heard this, it was like, what the hell is happening? The frame is supposed to just get out, right? I'm about to go. Now you hold that and you put a VXLAN header to it and then encapsulate it in the transport level as an UDP packet, UDP datagram, where you will have the source port number and the destination port number. And then this is added with the outer IP, which contains the source IP and the destination IP. Now, what will that IP be? I don't know, but it's some IP added there. And finally, it is encapsulated into the outer Ethernet frame which contains the source MAC and the destination MAC. Okay. At least it is not new to us, right? This portion is a little new. It will add the VXLAN header and the UDP segment. But apart from that, it's not like very new to us. Why? Because we saw this. We saw this in OTV. We saw a similar thing in Fabric Path. In OTV, it was the source join interface IP, destination join interface IP addresses, right? But now here, what is the IP address? Which IP should I give? So what am I saying here? I'm saying when the frame comes, like 10.5 trying to communicate to 10.6, when the frame comes here, I am going to encapsulate it with a VXLAN header, put a UDP source destination port, and then I give the source IP destination IP. Source IP destination IP. What would that be? So in order to understand that, I think you might have made a guess, but in order to understand that, one terminology is important. We call these leaf and the spines, we call them as VTEPs. VXLAN tunnel endpoints. Now what they are is basically the devices which are going to encapsulate the frames into VXLAN, decapsulate the VXLAN frames into Ethernet, and those who route based on the VXLAN packet. So in other words, any box that is using, creating, or manipulating VXLAN frames, they are all VTEPs. So from our setup perspective, every leaf and every spine is a VTEP. So what we have done is, for each of these leaf and the spines, a IP address will be given. So each of them will have a IP address. So 1.1, 1.2, 1.3, 1.10, 1.11. So they'll have IP addresses like this. Okay, now how did they get these IP addresses? Well, you configure a loopback interface, give it an IP address. Remember, these IPs are required in the fabric between the leaf and the spine. When they send the packets in the fabric, they need this IP address. So what we do is, from a configuration perspective, we simply configure a loopback, anything doesn't matter. We give it an IP address, and to the physical interfaces, like Ethernet 1/25, for example, IP unnumbered loopback 1. For interface 1/26, the other ports, IP unnumbered loopback 1. Very old stuff, right? IP unnumbered is a very old thing. We used to use that in PPP, multi-links and all. So what it basically does is, each VTEP, leaf and the spine, they will just use one IP address. Physically, I may connect any number of connections. I can connect like this, I can connect like this, I have another spine, I can connect it to that. Doesn't matter. All of them are going to just use this IP address. One single IP address for individual VTEPs. So that is how you will have a IP to each of these devices. Okay, so now I know when 10.5 wants to communicate to 10.6, the packet will contain 1.1 as the source, and the destination of that packet will be 1.3. 1.1 and 1.3. Almost like your fabric path, right? In the fabric path, we had a switch ID, source switch ID and the destination switch ID. In OTV, we had join interface IP address. So they combined it. Okay, why can't I use the same IP address logic in the fabric also. Why do I need a switch ID and all? I will just use IPs. Super simple logic. Now I can use the VXLAN in the data center. If I have to communicate to another DCI, I can also use VXLAN for that. Exactly the same logic. Instead of calling that as an edge device, I will now call it as a VTEP. Okay. So overall flow, I got it. I will have my original Ethernet frame 5A communicating to 6A. I will have my VXLAN header, does something there, and then UDP packet, and then my IP address is going to be source 1.1, destination 1.3. In the fabric, it is going to be routed based on the 1.3 IP address. Now, by the way, the frame will contain, for example, loopback 1 I'm using, right? So the MAC address of 1.1, whatever is the loopback interface MAC, I will use that. 1.3's MAC is what I'm going to use here. Okay. Again, technically I don't use 1.3, I will use the next hop MAC address, just like I do regular routing stuff. Okay. So this is the overall flow. Now the questions come. Again, the same questions, right? Which we had in Fabric Path, which we had in OTV. The same questions now. How will these devices know each other? First question. Second question, how will bump traffic be handled? So when 10.5 wants to communicate to 10.6, it will send an R, which is a broadcast. So how is it sent to others? Same questions I'll have to answer. Now, you need to have, in order for bump traffic, okay, there are a couple of things which you can do. You can enable what we call unicast routing. You can enable unicast routing for unknown unicast. You can explicitly enable ARP flooding. Explicitly enable ARP flooding. And as you can say, this is for ARP broadcast. This is one alternative for unknown unicast and for ARP broadcast. But there will be other broadcasts, right? DHCP can send broadcast, whatever applications they may have other broadcast messages, and multicasting can be done. Okay. For that, you have to build, I will say that. You will have to build and use multi-destination trees. Just like what we had with the Fabric Path, right? We have to use multi-destination trees. Okay. How will this work? How will this happen? Now, this is where, if you do manual configuration, remember I told you you can do the manual configuration with VXLAN, 7K, 9K, or any other box that supports VXLAN. You are the one who should configure all of this on a per BD basis. On a per bridge domain basis, you will have to configure these multi-destination trees, enabling unicast routing and ARP threading. You have to do this manually. Okay. Now, if you observe very closely, it's very difficult to observe. I said this as bridge domain. I did not call this as broadcast domain. I call it as a bridge domain. Okay. For now, just think of this as a broadcast domain. It is actually. Okay. is actually a broadcast domain. There are differences, important differences. But for now, think of it like broadcast domain, equal bridge domain, equal VLAN for a generic understanding at this point. So you will have to do this manually on a broadcast domain, bridge domain basis, on a per group basis, you will have to. But if you leave it for ACI, to do it, ACI will run again ISIS in the fabric. Now this time it is not used to exchange the switch IDs, it is actually used to exchange the VTEP IP addresses. They form neighbor adjacencies with each other, they know how to reach each other in their routing tables, they have their topology views built, and ISIS is also used to build the multi-destination trees. Just exactly like what, how I used ISIS in Fabric Path. But this time, it is not exchanging the switch IDs, it is actually exchanging the IP addresses of the VTEPs. Okay. There is another protocol called COOP, which is used to exchange the databases. The MAC database information is exchanged using a protocol called COOP. Again, this is all ACI related. COOP is called Council of Oracle Protocol. Okay. I think I understand ISIS. So now I know if I have to go from 1.1 to 1.3, I know what is the path to use. If I have multiple paths, I can do ECMP. I know that. But what is this COOP? Can you explain that packet flow like we explained in Fabric Path, right? We explained it in Fabric Path, we explained it in OTV, when a packet comes, when an R broadcast comes. Can you explain that? Can you be clear about it? Yes. Here is the thing. Whenever a frame comes to any leaf, okay? Whenever a frame comes to any leaf, that leaf immediately updates the process. ISIS is the one which is used to form the routing adjacencies, know the neighbors, topology view, and the multi-destination trees. All of that is taken care by ISIS, pretty much like Fabric Path. Now there is this protocol called COOP. What is the purpose of it? Why do I need it? In one line, it is used to update the MAC address information. But in order to really thoroughly understand this, I want to first highlight this Anycast address, which is used everywhere in VXLAN and ACI. So what is this Anycast address? Again, this is not a new addressing schema. This is there right from the beginning. We just never used it that much. We know unicast address, one source, one destination. Multicast address, one source, many destinations. And broadcast address, one source, all destinations. And then you have this unicast address, which is there, like right from the beginning, it is there. This is one source to the nearest. This is what what did I say? Anycast address. This is what is an Anycast address. Again, this was there right from the beginning. Now, what is this? How this was used? Now, once upon a time, this was our load balancer. Okay, we used to have these web servers. This used to have an IP address of 10.5. There is another branch of it. We had a web server. This used to have an IP address of 10.5. another web server. This used to have an IP address of 10.5. Now, if you look from a basic design perspective, this is a completely wrong design, right? Why? Because uniqueness is not there. This is connected to ISP1. Maybe in US, this is connected to India, ISP2, and this is connected to Europe, ISP3. So you have a connection to these local ISPs. Each of your branches, the web servers, the web hosting company, they have the same IP address. The ISPs are connected to each other, directly or indirectly. So if you look at the routing tables of these ISPs, you will see the 10.0 network in 3 different places. It is this side, and this side. Same IP. I mean, it's a unicast IP. It's a single IP address. But what you did was you assigned that unicast IP address to all the systems in different places. Why would I do that? Now, here is the thing. If there is a customer client in US trying to access 10.5, which is the web server, the request will be made to the nearest web server. Because according to its routing table, 10.0 is in 3 places. Whichever is the best path, I will go there. As long as the local connection is there, my data would go to this server. My request will go to this server. Similarly, if a client in India is trying to access the same web server, it's the same IP. The ISP2 also has 3 routes, but it will take me to the nearest. Basic routing, right? It will take me to the nearest. If, for example, there is a server, if there's a client connected to something in the middle, I would have multiple paths, and if, let us say, both of them are equal paths, then I would simply load balance. That's how we used to use this anycast address. It's a unicast address assigned to multiple systems. So whenever I want to communicate to that particular address, I will be going to the closest, whichever is nearest. All of these systems, in this case the servers, are using or assigned the same IP. Load balancing is what I can do. If the link goes down here, the client can go to the next available server. This gives me resilience, backup routes. This is anycast. We used it very long time in the beginning of internet. We used that. Later it became, multiple other technologies came and it became very different from what we were using. Okay. Secondly, the applications were also dynamic. Now this will work if the databases are in sync with each other, like all the pages are there in all the servers. So there's no mismatch in the databases and all. But once the applications became dynamic, synchronizing them became a very big challenge. Okay, so for those reasons, we did not use anycast that much. So anycast, it's just a unicast address, but you assign it to multiple devices. So when a system tries to access that anycast address, which is assigned to multiple devices, I will simply go to the closest one. They all will share the same address. That is what anycast address is. And that is what they started using in this VXLAN scenario. So both the spines, they have their own VTEP IP, 1.10, 1.11. But both will use what they call proxy spine IP, which is a anycast address used by all the spines, shared by all the spines. So if you look at the routing tables of any of these leads, you will see the address 1.110/32 network reachable in this and in this with a metric of 1 hop, whatever the metric of the hop is. So what happens? Why do I need this? Now we will understand. So let me go back to the scenario. 10.5 wants to communicate to 10.6, and even before that happens, when at least one frame comes to the leaf, the leaf will learn the source IP, source MAC, and the source port number, which is almost like a MAC address table. But this time the beauty is not only that I will learn the MAC address, but I will also learn the IP address of it and the corresponding port. And as soon as a leaf learns about it, it will immediately send this to a proxy spine IP. So it will send it to 1.110. Maybe first update I will send it to this, second update I will send it to this. So load balance. As soon as a proxy spine receives it, the spines will sync with each other, the database. Now, all of this is happening with the protocol COOP. So they built another protocol, COOP, for that purpose. If you observed, if you try to correlate, in OTV, ISIS was doing it, right? Whenever the edge device learns a MAC, it will immediately updating it to the other edge devices. But in the ACI and in the VXLAN, they used this other protocol. In ACI, they used COOP. If I want to do it on my own, like without ACI, if I want to do it, I can use BGP EVPN address family. This is what I will use. This is in a non-ACI environment. So BGP, we saw VPN v4 address family, which was exchanging VPN v4 routes, RD and the network. Now BGP EVPN is used to exchange MAC address information. So what we do is we will create BGP adjacency, we will create route reflectors as spines, and then we will start exchanging the MAC addresses. Again, this is non-ACI setup. But in ACI, there's no such choice. COOP is the protocol that is going to run. So what am I telling you? I am telling you, if a leaf receives at least one frame, okay, from any of the systems connected, immediately it will send it to the COOP database in the spines. Remember, it is not sent to other leaf. It is only sending it to the spine. The spine maintains it in what is called as mapping database. It will maintain the IP address, source IP, the source MAC address, and the VTEP IP address, the source VTEP IP address. In this case, it's going to be 1.1. Similarly, if 10.6 is communicating at least one frame, then I will learn that and the database. Okay. Is it fair? Is it fair to say, if you connect a system to the leaf, at least one frame will be sent? One frame will be sent to the leaf? Yeah, I think so. So, ideally, your mapping database should contain all the information about every system connected to the fabric. Wow. Like, really, it will have all of it? Yes. Cisco initially came up with the number 1 million endpoints. They now call them as endpoints. And in the current versions, in the last 3 years, I think, they made it 2 million. 1 million is 10 lakhs. 2 million is 20 lakhs. So that's a lot of database they can hold. Yes. So at least one frame comes, they will know it. So here is what happens. When 10.5 wants to communicate to 10.6, it will first send an ARP request, ARP broadcast. When it sends an ARP broadcast request, the leaf knows that it is an ARP broadcast. Not only that it's broadcast, but it's a special ARP broadcast. So by default, ARP flooding is disabled. Now, because ARP flooding is disabled by default, what happens is, as soon as an ARP request comes, it will send it to the proxy spine. It could be sent to 201 or 202. Once the ARP request comes to the proxy spine will see if it is in the mapping database. Okay, you are trying to communicate to 10.6. So I know where 10.6 is. Now, that ARP broadcast will be now sent as a unicast from the spine directly to that destination leaf, wherever the destination is. When the leaf receives this, it knows it is a broadcast. It already knows where 10.6 is because it is maintaining in its own local table. By the way, we call this as local station table. It will directly send it to that. See what happened. A broadcast, I did not even send as a broadcast here. I just sent it as a unicast to the destination leaf, all because I was able to get the updates of everything using the kube database, kube protocol and kube exchange. That is what happens with our broadcast. Okay. It is very, very safe to say at least one frame will come from 10.6. Very safe to say. But let us say I'm pinging to something which is not even there. Or corner case, let us say there is not a single frame coming from this 10.6. In that case, the leaf will not know. If the leaf doesn't know, it won't send it to the spine. So the point is, if an ARP broadcast comes and the leaf sends it to the spine because ARP threading is disabled, if the spine doesn't know it, what the spine will do is, spine will sends a ARP broadcast request from its gateway address. Okay. See, 10.5 wants to communicate to 10.6. 5A is the source. Destination is, I don't know, so 12Fs. Gateway for 10.5 network is 10.1, let us say. Okay. We still did not know where the gateway is. Okay, we still don't know where the gateway is. That will come later. But understand for now, when the frame goes to the spine does not know where 10.6 is. So what it will do is, it will discard the original ARP. Whatever ARP came from 10.5, it will be discarded. And the spine itself will send a ARP broadcast as if the request is coming from the gateway, which is 10.1. So again, where is 10.1 exactly? We don't know. We will have to yet answer it. But for now, understand, the spine will act like the gateway and it will ask the 10.1 network, 10.x network, with its own IP address, the gateway IP address. So inevitably, the packet will go to the other leaves and everybody will send it to everybody else in that VLAN and response should be coming. Okay. So this is what happens if the spine does not know where the destination is. Very unlikely event, but if that happens. Okay. Now, if an unknown unicast comes, that means the frame is coming from 10.5 to 10.7. Maybe I gave the ARP entry in the system manually for 10.7. So a unicast packet is coming. But the leaf does not know where 10.7 is. It does not know. So if it does not know where 10.7 is, again, it will send it to the proxy spine. Now that is the master database now. Now this is not an ARP, this is an unicast. If the frame comes to the spine and the spine says, okay, 10.7 is 7A connected to 1.3. If that information is there, meaning At least if one frame comes, that information will be there. So if the information is there, it will directly send it to that destination leaf. Okay. What if, just like before, what if this is a silent host and it is not responding? In that case, listen carefully, in that case, unknown unicast packet will be dropped. It just will be dropped. I'm not going to react. No. It's a very, very, very unlikely event. System knows the MAC, it seems, but the fabric does not know it, it seems. Very unlikely event. So in that case, the packets for unknown will be dropped. Okay. So what I told you just now, when a frame comes, leaf does not know where it is, it will send it to the spine. This behavior is called unicast routing. This is applicable for that unknown unicast. So now it makes sense, right? Now, what if you have other types of messages like multicast messages or broadcast messages other than ARP? If you have any of such things, what you will do is you will use the multi-destination trees created by ISIS. Now, in Fabric Path, I hope you remember, 2 trees will be built. But whereas in VXLAN with ACI, up to 12 trees are built. 12 multi-destination trees will be built. So I will use that multi-destination tree and send it to all the leaves, and from there it goes to the respective VLANs. Okay. So this is how the packet flow works. Now, here is one last point I want to tell. You can enable ARP threading. If you don't enable, it goes to the spine and the spine will unicast, right? But you can enable ARP threading. You can also disable unicast routing. Now, for example, if you disable unicast routing and enable ARP threading, in that case, when you get an unknown unicast or when you get a ARP broadcast, you are going to now use the multi-destination trees. So everybody will use multi-destination trees. Okay. If you learned the MAC address from the data plane, you will send it directly to that leaf. If you did not learn, you will just send it as you will just send using the multi-destination trees. That's how the data flow happens in VXLAN. Okay. Are we clear with this flow? Okay. So if you look at this, yeah.
Kalyan, so when 10.5 will send the, he will be communicating with 10.6. So request will reach on both spine or only respective spine like 201?
It will send it to proxy spine IP address. The request will be sent to proxy spine IP address.
Okay.
So which one? Both of them are there. So maybe the first request coming, I will send it to this one. Second request, I will send it to this one. So load balance. Both of them are synchronizing the databases already, right? So both will have the same mapping database.
Okay.
And Kalyan, what about means 10.106 will receive 2 copies, or at a time only one spine will send the forward the traffic to the 10.
Always load balancing is one at a time, not both.
Okay,
right?
Means this proxy spine IP is just like the VIP in HSRP.
Very, very loosely you can say that. The only difference is VIP address, only one is active at a time. Unicast address, all are active at the same time. Are we clear?
Okay, so can we that it is acting like that? Is it?
Yeah. Yes. Yeah. Definitely you can think that.
Proxy spine IP.
Any cast IP, keep that in mind. In this case, that any cast IP is used by the both spines, and therefore we call it proxy spine.
Okay.
All right. So that is done. Now, because I am using, or rather because I am routing in the fabric, do you think I answered the first question? Instead of using one link, instead of using VPC or something like that, instead of using even fabric path, can I say I can randomly use any number of links and I can start building up my bandwidth and I can start using all the links and do load balancing? Did I answer that? Is that problem solved? Yes or no?
No.
Why no? Explain. Give me the problem. Yeah, Deepak. Why did you say no? And that too very quickly.
Yeah, Kalyan, actually we are forwarding the traffic both of links, but at a time one is spine is forwarding the traffic to the 10.6.
Wrong. I am doing load balancing. Let us say 20 flows are coming here. Am I using both the links? Yes or no?
Yes.
Simultaneously?
Yeah. Yes.
Why did you say the problem is not solved? I have another link here. Now 3 links are there. Will I use all the 3 links? Can I take 20 flows and share them? 6, 6, 7, something like that?
From means leaf 101 perspective is forwarding the traffic from both of links. But what about in spines?
If I was having only one active device, all the 20 flows would have come to one spine. Now 10 flows are coming to this. This is the one sending it to the right leaf, right? And when the frame comes to this, when the remaining 10 flows come to the second switch, it is sending it simultaneously to this. If you are going to the same leaf also, the 10 flows that switch 201 received, it is sending on a separate link. The 10 flows that come to switch 202, that is sent on a separate link. All the links are being used, right? Yes or no?
Yeah, yes.
I added another spine connected to that leaf. Can I use all the 3 links now? Can I load share between all the 3 spines? Absolutely yes. Is the problem solved?
So is this the advanced technology of fabric path?
Exactly. The fabric path, if you compare it with VXLAN from a data flow, from a routing perspective, very identical. One advancement is that instead of using a switch ID, which is Cisco proprietary thing, I was using IP packets. I was giving these, instead of a switch ID, I'm giving a VTAP IP address. That's the key difference and the major difference. Job done. No port channeling, no VPC, nothing.
Okay. So in fabric path, once we decided how to route the frame, it will be sent to only one switch, upstream switch, and then it will.
In fabric path also, once I know that I have to go to switch ID number 3, if I have multiple paths to go there, I will do load balance there also, na?
Yes.
Yeah. So very identical. Because we already learned fabric path, when you compare that with VXLAN, very identical. They are both doing routing the frame only. Advantage is now VXLAN is using just IP packets, which is open to everybody. Instead of some switch ID, some packet format, different, all that. Okay.
Okay, in that
So
case,
again,
both are very identical. Is there any case whether we should only go with VXLAN or fabric path? Because both are not much difference. Is there any scenario where we should only go with VXLAN or fabric path?
Fabric path is only capable within certain line card models of within Cisco devices. See how much narrow it is. Okay, we talked about that. Fabric path, everything is good, but the only problem is that it is a proprietary lock. For today, if the box supports both fabric path and VXLAN, all right, that's where the real answer comes, right? If it is not supporting fabric path, then go for VXLAN. It's a simple answer, straightforward answer. But if the boxes are supporting both fabric path and VXLAN, which one should I choose? Vote will go for VXLAN only. VXLAN is the winner. Okay? Any questions?
Kalyan, again, this is within data center only. Am I correct?
No, it can be applicable between data centers also.
Means we can connect two data centers, DC like DCI, data center
Exactly.
interconnect.
Now I will have my leaf, for example. Now this time it is not called an edge. It is simply called as a VTEP. The data frames, the Ethernet frames are coming here. I will encapsulate that into VTEP IP address, which could be the interface IP here, connecting through the DCI, going to the other side edge device, which we call VTEP again, and then I go through the Ethernet. Same logic. Observe this. Instead of frame coming from the leaf of a data center, now the data is coming from the leaf of my edge device. I am encapsulating into VXLAN, which is nothing but an IP packet, and I can send it to the other side.
Okay, here
on the other side, I can decapsulate and send it as a Ethernet frame, just like leaf 103 is receiving it. So this is the other beauty of it. I can use it within the data center. I can also use it across the data center.
Means no OTV is there in this case.
Nothing. Gone. OTV.
Okay.
All right. So this point is clear. Yes, I have succeeded in using multiple links without STP, without fabric path, lock in the proprietary shape. I can even have not 4, but I can have 6 or any number of spines. I think at this point 6 is the maximum, but they are increasing that number as well. Okay, so and again 6 is the maximum for ACI. That may also change, but for non-ACI, if I want to use VXLAN, I'm in no limit. Okay, so I can do that. But how about the second question? Gateway choking. How do I solve that problem? This is where things get like super crazy. Like super crazy. I mean, concept is simple, but for an old network engineer, it is very difficult to digest. So let us say there is this spine network, 1, 2, 3, I don't care. All other leaves are connected to the spine. Leaf 101, leaf 102, leaf 103, leaf 104. And you have a network 10.5, maybe this is 10.6, and then this is 20.7, this is 20.8. So where is the gateway For 10.5, if it wants to communicate to 10.6, I don't need the gateway. But if 10.5 wants to communicate to 20.x, let it be here or let it be there, I need to go to the gateway. In this example, let us say gateway 10.1 and 20.1. Where is the gateway? It is, for me, I felt like cheating.
So shouldn't it be connected to 102 and 103?
101, 103? Where?
102 and 103.
What should be connected? Gateway?
Yeah.
Oh my God. Why did you say that? That's a very bad design. I mean, my systems are here on 101, 104. Why did you say the gateway will be on 102, 103? If you said it is on leaf 101 or 104, at least I would have felt a little happy. Wow. Why do you put it here? I don't know why you gave that answer.
But it should be on the spines.
The gateway is on leaf 101. The gateway is on leaf 102. The gateway is on leaf 103. The gateway is on leaf 104. The gateway for all the VLANs, all the bridge domains, are on all the leaf.
Kalyan, is it as same as in the 3-tier core distribution and access?
In the core distribution access, we had the gateway on the distribution layer switches.
Yes. Is
and
it
it
as
was
same?
one active per group. But here, you brought it to the leaf, like right at the axis, if you compare. And it is not in one place. It is everywhere. Now the question, I think one of you gave an answer, which is interesting. Akhil said because VXLAN layer 3, that's why. Not really. It can be anything, okay? Let us say VXLAN is, it's not layer 3 per se. It is because you're taking an IP packet, you're taking an Ethernet frame, and then you are adding a VXLAN header, and then you are taking an UDP, okay? Whenever you are encapsulating anything in UDP or TCP, where do you put VXLAN there? I mean, where do you put the payload? Interesting question, right? Make a guess. If you are putting any payload in TCP or UDP, what is the payload? Where should the payload come from? It should be coming from application, right? What is this spine? What do you mean by spine, Akhil? You are talking layers and suddenly you went to the physical boxes. Anyway, so it is not a particular layer thing, okay? Yes, you can call it as layer 2 ID for, if you look at it from the VNID perspective, which we are yet to discover. You can also, you also have something called the layer 3 VNID, which can put you in the layer 3 as well, okay? So it can be in either 2 or 3 and both at the same time. That is not the point. Whatever layer VXLAN is, my fundamental thing is, how can I have a single IP address given to multiple devices and still I don't have any problem? My fundamental rule is a IP should be unique in the network. Otherwise, you have IP conflict. But now they say this is called all these gateways, they are called as anycast gateways. Some documentations will call this as pervasive gateway. So gateway is here, it seems. Like everybody will have it, it seems. Now that's an amazing thing. No conflict? Yeah, no conflict. I'll tell you one more internal detail. This will have a MAC address, right? And this should also have another MAC address. But the answer is, all the gateways, like you have 100 VLANs, 100 VXLANs, and then you have 100 gateways here. All the 100 gateways will have the same MAC address. They use a reserved MAC address. They use the same MAC address. What? Yeah, no problem. It's just an identity. That's all. Quite amazing. So now see what happens. If 10.5 wants to communicate with 20.7, if the leaf already knows where 10.5 is and 20.7 are, because I maintain the local station table, right? I have the IP address, I have the MAC address, and also the port or the VTEP, whatever. Port is in the local station table. If I have both the information, when will I have it? If at least one frame comes, I will have it. Immediately I do routing here itself. I don't use a single link in the spine. Gone. I don't use it. But if I want to communicate from 10.5 to 20.8, I get here, I look at the MAC address, destination MAC. Remember, when 10.5 wants to communicate to 20.8, the request will go to the gateway. I am the gateway. So I look into the packet. When I look into the packet 20.8, do I have it in my table? Maybe because of prior communication? No, I don't have it. Okay, I will send it to the spine. Now spine knows exactly where 20.8 is because of the COOP updates. I will directly send it here. Now the burden of the gateway is distributed to every leaf. Not one leaf, not two leaves, not four leaves. You have 20 leaves in the network, all the 20 leaf is acting like a gateway. If I want to communicate to a destination which happens to be in the same leaf, I don't even use the spine. If I have to go to a destination which is not directly connected to me, I will give the information to the spine, and the spine will send it directly to the destination leaf. I mean, it's like magic, like everybody knows everything. At least they know whom to contact, and that spine knows everything. Wow. That's quite amazing. Any questions here now?
So, Kalyan, actually, I wanted to ask, is it as same as SVI we created in previous switches?
Exactly. Exactly the same.
But here in ACI, we are configuring the gateway on every leaves. We can say on every switches.
Exactly. When you go with ACI, this is done automatically for us. When you go for a non-ACI environment, you go and create the SVI in each of the switches relevant. And once you give the IP address, you will give that one extra command, anycast gateway. You go into the SVI, you create an IP, and then you say anycast gateway. Once you say that, that is the IP that every other leaf is going to use. So basically, you have 20 leaf, you go and create the same SVI on all the 20 leaves, and you simply give the command anycast gateway, and that's it. That's the manual configuration, non-ACI environment. But in ACI, this is also done automatically. Yes. Are we clear? So now did I answer? See how simple it was. It was almost like cheating. Did I answer the second question of gateway choking point? Gone. Just gone. Every leaf is acting like a gateway. That was super. Okay. Now, I want to take a break here. Okay. I want to take a break and we will come back after lunch. And once we come back after lunch, I will talk about another thing, okay, another important thing. See, if you look at the discussion of VXLAN up till this point, right? Up till this point, if you look at it, it's convincing, okay? At least the last point, gateway is put on the access leaf and everybody is acting like a gateway. So distribution of the load is there. That's convincing, but still, okay, you're just routing the packets. You're just routing. You're just routing the frames. That's what you're doing. Is there anything else VXLAN can do? Is there any other advantages I have by using VXLAN? Remember, I told you, one of you asked the question, right? So when to use fabric path, when to use VXLAN, and I say if both the technologies are supported by the boxes, VXLAN will always win, I said. VXLAN will always win, I said. But nobody asked me why. End of the day, both are doing the same thing. So then why should VXLAN win when all the boxes are supporting fabric path? So there is another important construct they brought into VXLAN. And that construct is called bridge domain. So we will take the break, we will come back, and then we will talk about this bridge domain, how the concept is, what is it different from. And once we talk about this, we will, talk about this ACI stuff. What exactly is ACI? And then we will wind up the session. Okay. So initially I thought, okay, I will push it and finish it off. But then, no, let us finish it in proper manner. Okay. So we'll come back by 2 o'clock, guys. We'll come back by 2 and then we will continue. Okay.
Okay,
because we learned fabric path and OTV, it may not be a wow factor. Yeah, okay. VXLAN will also do this stuff. But if you learned VXLAN without learning those two, then it would be a wow factor. But as I said, if that is the only reason why I have to use VXLAN, I don't know, maybe fabric path would also win the race. Of course, Cisco proprietary and all, but maybe. Is there anything else that VXLAN brings into the picture that I want to use the word revolutionize the whole networking idea? Like completely change the thinking of a network engineer. Is there anything? And the answer is yes, absolutely yes. This is what they brought. They brought two constructs. With VXLAN, we have two constructs. One is called the bridge domain, and the other one is called endpoint groups. EPGs, we call them. When you look at the actual VXLAN header, that endpoint group is identified with a number, it's just a tag called security group tag. Okay, anybody from firewall security background, they probably will understand what this is. When it comes to ASA firewalls or anything, when you create your access list, we don't create it with on a source destination basis. I mean, we do it on source destination, but then the way we do it is different. We create groups and then we apply. but that is different here, slightly different here. So let us try to understand these two things, endpoint group and bridge domain. What are they? Now, in order to understand both of them, I need to understand how I, as a network engineer, how I am used to thinking. How am I used to thinking? This is how I am used to thinking, right? I would have my network. I don't care VXLAN. I don't care fabric path. I don't care VPC. I don't care any of that. For me, it is all about VLANs. Think about it. For me, it is all about VLANs. There is an application which has got 20 tiers. I don't care. North, south traffic, east, west, I don't care. I mean, you don't even talk to me like that. For me, how many systems are required? Do you want me to put it in a separate group? That's what I want. 2 Excel sheets I have. One for the available networks, one for the VLANs. Whenever somebody comes to us from a business and they say that we want so many, if a client is saying that I want so many hosts, you will say, VM guys or whoever is the system administrator, you say that, bring up these 3 VMs or bring up these 4 servers. From our side, we will give a VLAN ID. We are going to configure the VLAN on a respective gateway or distribution layer switch. And we will configure HSRP or VRRP, whatever. And we will, according to our load balancing schema, if there are already 20 VLANs, this device acting like a gateway, we will give one here. Okay, maybe 20 are here, 10 are here. Depending on the group, we will give. We will go into each of the switches and we will configure the VLAN because we generally want to go for VTP transparent, right? So we will give all the VLANs in all the switches. And the trunk ports. Good practice, a lot of people don't do it, but good practice is to not allow all the VLANs by default. Allow only the VLANs that are actually in the environment. So every time you add a new VLAN, you just allow that VLAN in the trunk. Yeah, that's what you do. Then you go to the firewall, you configure the security rules. And if you prefer to have higher security, maybe the gateway will be on the firewall itself. Remember, here you will also have service nodes, load balancer you can give, or firewall you can give, whatever you are giving. This is your job. This is what we do. A VLAN, one network, and go and do the respective configuration on the boxes. This is what we do. Now, this VLAN has to be unique in the whole setup. So if I say I'm giving a VLAN number 55 for the business unit 1, and which is, I don't know, some sales application or whatever, this is it. Whether I go to the 50th switch, whether I go to the 20th switch, whether I go to the second switch, this is what it is. 55 is for that particular VLAN. Wherever it is, I don't care. Meaning the VLAN which you are going to create is globally significant. One VLAN will get one network. So they said they wanted 4 IP addresses. They said they want 4 IP addresses. But if they want 4 servers, we need 3 IPs for the gateway. If I'm running VRRP, I can need only 2 gateway IPs. If I'm having any firewalls in the middle, go to or go through like transparent or routed mode, you may need another IP address for the firewall. And maybe if you wanted to do some load balancing because those 5 IPs are for the same type of servers, maybe another IP address. So you count all of this. You count all of these and then say, okay, they need 4 plus we need these. So total of 10. So we will give a network with a /28. So total of 14 valid IPs you will get in this. So you will give it. Tomorrow they'll come and say, can you give me another 5 IPs, please? Gone. My VLAN, that will be the same, that much okay, but my gateway configuration will change. My security firewall rules will change. Because now this network is no more valid. I'll have to give a /27. So I have to go to the server guys and say, change your subnet mask, change the gateway. Maybe I will change the gateway also because you don't have this immediate block. You may not just convert, like for example, .32 directly to a 27. Maybe that block is already given. So maybe you have to give a completely different network from your Excel sheet. So gateways may also change. So all of this is change, right? All of this is a change management you'll have to go through. And I don't know about your company, about your client. Maybe they will have a very quick change management, just like that. And maybe you'll have to follow the rules. You have to give it to your manager. This manager will give it to the client manager. The client manager will give it to their manager, blah, 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 blah. So it's a lot of overhead from a management perspective. If you wanted to make a simple change of adding an extra 5 systems, it's a complicated process. It's almost like starting from the scratch. And remember, security. For everybody, I have to provide security. Okay. So they said, no, this is not the way we do things from here onwards. The fundamental idea of the VLAN is to separate that into a single broadcast domain. You are a separate group. For that, you have created a VLAN. For that, you have given one network. That's the fundamental reason, right? We will not go with this. See the complete change of mindset. First of all, the way the VLAN is used, the VLAN is going to be used to identify the end point group. We will use the VLAN. Okay, we are still not getting rid of it. We will use the VLAN, but then the VLAN is not used to identify the broadcast domain. It is simply to identify the endpoint group. Oh, okay. So if I give a VLAN 55 here, that is for the business unit 1, and that is for sales application. Okay. You are not using it to identify the broadcast domain. You are simply using it to identify the endpoint group, a group of systems in a specific business unit, specific application, specific type of server. But if this ID should be unique in the entire topology, like if this VLAN is globally significant, then I don't really care whether you call it as VLAN bridge domain or VLAN endpoint group. I don't care. Still the same problem will be there. Because globally, I can have only that VLAN identifying that application or that group of systems. So in that case, in my entire setup, I can only have 4096 VLANs, some of them reserved and all that, around 4000 plus VLANs. That's all you can have. So you call it VLAN to broadcast domain mapping, or you call it VLAN to endpoint group mapping. End of the day, functionally, it's the same thing. They said this. The VLAN is now locally significant. It is not globally significant, it is locally significant. Oh, what does it mean? What does it mean to be locally significant? It means this. I can use on a single switch 4096 VLANs, not globally. Globally, I don't have to be unique. So what do I mean by that? If I have a system, let us try to put this guy in 10.x for now. If I have a system 10.5, which I want to put it in the VLAN endpoint group, I can say it is VLAN number 55 on this particular switch, on leaf 101. But on this leaf 104, for example, on this leaf, maybe 55 is already given for somebody else. Maybe there was another client for them already. There are some systems connected. We already gave 55 for them. So what I can do, I can now give another available VLAN in that switch. It doesn't have to be globally unique. So I'll give another VLAN here, and this can be, for example, it could be VLAN number 25 on this switch, which I will map to the same endpoint group. So now this VLAN to the endpoint group mapping is not done on a global level, it is done on a per switch level. Imagine the reusability factor. Now there is virtually there is no limit. 4096 VLANs, 4000 plus VLANs on every switch I can use independently, no problem. Imagine a customer in a cloud environment, public cloud, hundreds of VLANs, hundreds of customers. That would be like thousands of VLANs, very easy. Not just 4,000, thousands, tens of thousands. Doesn't matter. Because now the VLAN is simply for that particular switch. I don't mind. I can reuse it. If I am lucky, like my private data center, for example, yeah, I can maintain 55 here. I can also maintain 55 here. Okay. Within a private data center, 4,000 is a big number. Okay. In a public cloud environment, that is where the challenge comes. Otherwise, if you have a setup, like for example, there are some companies, I don't know how yours is working. Maybe you have your own infrastructure, your own data center, right? And then you have clients. You take their client request and you will use the data center for all the clients. So that is going to be a kind of, it's a public, but then you don't give it to everybody. You just give it to those who pay for it. So something like that, infrastructure as a service. So in such a case also, now the scale is no problem at all. Absolutely no problem. Okay. So I can use the same VLAN or I can use a different VLAN also. The way I do the mapping is that the VLAN in both the cases, even though they are different, I map it to the same endpoint group. That is one major advantage. I mean, completely thinking is gone, right? VLAN is one network. It's unique for every company, every department. Now that's gone. Okay. But still, they both are in the same domain. See, this is also 10.6. 10.6. Then there is something else, 10.7. So if somebody wants to communicate to send a broadcast message or send an unknown unicast message, they have to go to the whole setup here, right? Yes, they'll have to go to the whole setup. So how do you put that in a single broadcast domain? How do you do that? And that is where they have this concept of bridge domain. Okay. You still want to put them in a single network wise, in a single group. Your bump traffic goes inside that, all of that you want to do. So that is what you define in bridge domain. Okay. The bridge domain, coincidentally, the acronym is the same. Broadcast domain is called BD. Bridge domain is also called BD. One broadcast domain is equal to one bridge domain. So traditional broadcast domain is one bridge domain, and that is identified with one unique VNID. So now VLAN, which I used for broadcast domain, now I will use that as a EPG. It is used to identify the endpoint group. Okay. 2, if I wanted to put all of them in a single broadcast domain, I will keep that in a separate unique VNID. Now I identify the broadcast domain with a VXLAN network identification number. Now, should that be unique globally? Yes or no? Make a guess.
Yes.
Yes.
Very good. Very good. So you're following. Very good. So that must be unique. So somewhere I need to know that it's globally, or there are systems connected to switch 20, switch 50, switch 2, switch 10. All of that are in a single group. I should know that. Something should be there. And that is now not VLAN, but now the VXLAN network identifier, which happens to be 24-bit, which gives me 16 million. At least as on today, we say it is virtually unlimited, no problems. We don't know in the future what happens, but at least for now, 16 million is a very good number. Left, right, and center I can give. Okay, so this is what your broadcast domain is now going to be. So the way you do this is, now you will have a bridge domain. You will have a bridge domain to which you will have multiple EPGs you can associate. From the explanation I gave you, the VLAN is mapped to the EPG, and then the EPGs are now mapped to the broadcast domain. Bridge domain, we call it. So it may look like, okay, one VLAN to one EPG to one bridge domain. No. That is not the case. The case is the VLAN, which is locally significant, by the way, I will map it to the EPG, and that EPG is mapped to the bridge domain, which means I can have multiple EPGs based on the VLAN ID. I can keep them separate into multiple VLANs into multiple EPGs, but they all will be still in the same bridge domain. Wow. See what is happening. Which means 10.5, I can put it in VLAN 55 and map this to EPG 1. 10.6 map to 25. I can also put this in EPG 1, different VLAN, same EPG. I can also take another VLAN, for example, 55. Pay close attention. I can take 55 and I can put that in EPG number 2. Is that what I'm saying? Yes. And all these EPGs, EPG1, EPG2, and EPG3, all of them are in the same bridge domain? Exactly right. They're all in the same bridge domain. Network is all 10.x. The bridge domain is now your new broadcast domain, right? Previously it was VLAN. So you used to have SVIs. Now you will have BVIs, bridge virtual interfaces, to which you will configure the gateway. Now, as a side note, there are two ways of implementing. One is you can create BVIs. That's what we generally do in the service provider side with ASR, 1K, those kind of routers. You can also create an SVI for this. Instead of a BVI, it looks like an SVI, but it's a bridge virtual interface I can create. That is what happens in ACI. So two styles, like technically from a configuration perspective, you can do it in two styles. ACI will create another SVA for it. Okay. So see what happened now. They can be in the same network. They can be different VLAN or same VLAN, because VLAN is now locally significant. And I can put them in different EPGs. Yes. So what is the advantage? Why will I do that? Here is what happens from a security perspective. Within the VPG, communication by default happens only within the EPG. If you want to communicate between the EPGs, you can't communicate. Even though they are in the same network, even though they are sharing the same gateway, you can't have that communication happening. Does it imitate anything which you know from the traditional network? Just try to answer. Does it imitate anything that we know from a traditional network? Come on, someone should answer. No, not VRF. Not at all. I don't want to say not at all, but no. The private VLAN concept.
EPG routing through
private VLAN concept. It's the private VLAN concept, right? We have one VLAN under which you have secondary VLANs, and once you configure secondary VLANs in community, those systems in the same community can talk, but they can't talk to each other. Exactly the same logic. They have a new terminology, new tags used instead of a secondary VLAN and all. Each of these endpoint group will get a tag, a security group tag we call it, which is identified by the VLAN, incoming VLAN from the frames. And based on that, I isolate them. It's like your private VLANs. Wonderful. Now, difference again is VLANs are locally significant with regards to the VXLAN setup. Okay. So this is a completely new way of looking at things. Okay. Now, it's not over. Huh? The fantasy world is not over. One more thing. How many networks can you have in a single broadcast domain? How many networks can you have? Only one network. But now, with the bridge domain, I can add multiple networks to the same bridge domain. I can do that. So wait a minute. What are you saying? You are saying, so now if I have 20.5, 20.10, I can take them and I can put them in the same EPG, depending on the VLAN. It could be a different VLAN or the same VLAN. And I can still put it in the same bridge domain, same broadcast group. And the answer is yes. Why would I want that? Why would I want that, first of all? The answer is, remember I was telling you the history? Like when I wanted to have, where is that? When I wanted to have extra 4 systems. When I wanted to have an extra 4 systems, did I write it? Whatever, forget. So when I wanted to have extra 4 systems, remember I was using a /27. Now I wanted extra 4 systems. Now it's not a big problem. It's not at all a big problem. All that you do is add another network. It doesn't have to be the same parent network. It doesn't have to be the same class. Nothing. It could be any other network. I just add another /28 or 29, whatever. I'll just add it. Now that SVI, which we have, now it will start to have multiple IP addresses. So all the systems here are now going to, have the SVI, single SVI. Previously, for every VLAN, one network. For every network, one SVI. And each one will have one IP. But now, you want all of them in the same bridge domain, so only one SVI, but now you will have primary IP, secondary IP, tertiary IP, any number of networks you can put into this. Okay. That is what really VXLAN brings into the picture. With this new construct of the EPG, I can separate not just based on the VLAN number, I can separate them on network addresses. I can separate them based on the port from which it is coming. I can separate them based on, some fancy stuff is also happening. VM attributes. Based on the name of the VM, I can put it into an EPG. What I just told you is one typical example. So I can group the endpoints depending on multiple criteria. I can put all of them in the same network, or I can have them in different networks. All of them identified with one VNID, which by itself gives me 16 million. Now, globally it has to be unique, but now I have a better scale. This is what gives me the real advantage of having VXLAN. So now with this extra information with you, I think you will answer the question, right? Which one will you choose, Fabric Path or VXLAN? Oh, yeah, definitely I'm going with VXLAN. Now, one of you asked the question, right? So you were using Arista. And now I think it makes a lot of sense. This could be in VLAN 25. This could be in VLAN 55. This could be in VLAN 45. I don't care. If I put all of them in EPG 1, and if I put all of them into the same bridge domain, meaning same VXLAN network identifier, same EPG, same VNID, can they talk to each other? Absolutely, yes. Now I hope not only that I answered the question, yes, they can communicate, but I also answered how they are communicating. Yes? Confirm?
Yes, Kalyan.
Okay, good. All right. So this is what happens with VXLAN. Super powerful, very flexible. Okay. So I want to draw the line here. I want to draw the line here for the VXLAN. Okay. So if we go beyond, we can talk a lot of stuff, how exactly this is going to happen, how the packet flows happen, one EPG to another EPG, multiple EPGs in the same bridge domain, multiple bridge domains. Okay. Multiple networks in the same bridge domain. So there is a lot of combinations here. Okay. So again, end of the day, the flow fundamentals are the same, but there are certain variations. But I'm not going there. Okay. I will draw the line here for VXLAN. However, I want to divert the attention to, okay, this is VXLAN. What is this then? Because without even introducing the concept of an ACI, I just talked about VXLAN. Here and there, when I started discussing VXLAN, I gave you certain differences. Like with ACI, you do certain protocols. Without ACI, you do certain protocols. With ACI, physically, there are certain conditions. Without ACI, there are some conditions. I gave you those like differences along the way. But what is ACI? Like, let us officially know what is ACI. Now, ACI is part of an SDN solution coming from Cisco. SD, I mean, today without SD, there is nothing, right? Last 5-6 years, every vendor, SD, software-defined storage, software-defined LAN, software-defined access, software-defined WAN, software-defined whatever. Everything is software-defined only. So what is this software-defined networking and what is the ACI? What is the components we want in the ACI? So we will talk about that and then we will wind up. So to discuss ACI, I need to know what SDN is, software-defined network is. And in order to understand what is SDN, I need to understand 3 different planes. One is the management plane, the other is the control plane, and the last is the data plane. You need to thoroughly understand what these are. Now, when it comes to the management plane, okay, management plane is your telnet, you SSH. Now, that is not the only management plane. If you go for F5 load balancer or some wireless controllers, there is, yes, you can do telnet and you can do SSH, but there is HTTP, there is HTTPS, right? So those are other ways, other interfaces through which you go into the device in order to configure the devices. So management plane is purely for configuration and troubleshooting. So this management plane was always, most part, it's always distributed. When I mean distributed, it means 200 boxes are there. I have to go to individual boxes to make a configuration. I have to do that. So distributed is what we have from traditional sense. Control plane. The control plane is anything, any protocol or any process that is going to establish the data plane. Any protocol or any program or any process that is going to establish the data plane. Okay, what do you mean by that? I'll give you a few examples. STP. STP. It's a control plane protocol which is used in order to decide, okay, there are multiple ways of going to a particular switched environment. Which one should be active? It will decide based on its process. So once STP decides, okay, this is the active port, my data, whenever it comes, it will go on that port. So STP is a control plane protocol that is establishing the data path. Okay, data comes, send it here, block it here. That's one example. The second example would be any routing protocol you take. So you have this router, you have these connections. Now I'm running any routing protocol, example OSPF or BGP, whatever. The protocol's job is to say, okay, I will find the best path to the network here, and it happens to be according to the metric or according to the policy, depends, right? This is the best path. So when a packet comes to 1.0, please send the packet in this direction. As a control plane, I am establishing the data path. I am telling, okay, go on that particular port, or maybe I will say use both the ports. I'm establishing the data path. This is another example of control plane. Another example could be any first hop redundancy protocols. Like for example, I have this router, and I have my switcher network. Now I have a system trying to access the gateway. So as a first hop redundancy protocol, HSRP, VRRP or GLBP, whatever, I am telling, okay, I will be the active router as the gateway. So if anybody is trying to communicate to 10.1, the gateway, I will take the packets and process them. If I am down, HSRP is identifying and detecting, and then this will become the active gateway. So again, here, it's a control protocol, a process running, deciding the data path. Where should I send the packets to reach that gateway? Now, I have deliberately taken these three very specific examples for control plane. One is layer 2, one is layer 3, the other one is falling right in the middle of it. So all of these are control planes. They are used, they are needed in order for me to establish those data paths. That's what a control plane does. Now, at this given point, from a traditional sense, the control plane is distributed. Obviously, right? STP is running on this. Is it enough? No, it has to run on this. It has to run on this. It has to run on this. You cannot have it in one place and magically things won't work. OSPF. Okay, if I run OSPF here, will it find the best path to all the networks? No, it won't find the best path. It has to run here, it has to run here, here. If I'm running a different routing process in both the directions, I have to do redistribution, and then the process is running on the other side. So the protocol, the control protocols of the process, it has to be distributed, it has to be everywhere. Same thing with your first hop redundancy. If I'm running HSRP in one place, magically will it detect? No, I have to run it on both the places. So the control protocols, the control plane at this point is distributed. And finally, the data plane, which is the silicon, right? This is where the packets are actually sent back and forth. This is where the packets get into this router. From here, it goes to the next router through this link. And then it goes to this router through other intermediate devices. And from there, it goes to the next router. When it comes to this switch, it will go to this switch port. And from there, it goes to the other switch port through this link. And then it goes to this port. Okay. This is all the data flow. This is how the data packets go. In the cable, on the wire, in wireless, on the air, whatever. This data plane is centralized or distributed. This is also distributed. Okay. It becomes ridiculous to do centralized data plane. Obviously, you don't put 1 mega box and all the devices won't connect to that. It just won't happen. So your data plane is also distributed. So basically, these are all the three different planes. And from a traditional sense, all the three are distributed. Now, here is the thought process. This happened like 12 years back, I would say, about 10 to 12 years back. They started thinking, okay, first of all, data plane. That's distributed. That should be distributed. That will always be distributed. You cannot change that. Right? You just can't change that. You will have 200 employees with 200 laptops, 200 desktops. They will be in different places. And you will have 200 branches. They will be in different places. And you need physical connectivity. they will be in different places. So data plane is always going to be distributed. You just can't avoid that. There is no optimization there. That's how it is going to be. So they were thinking, okay, I cannot do anything with the data plane. Of course, one thing I can do is improve the silicon. Throughput I can increase. CPU capacity I can increase. But that's it. It's always going to be distributed. So I cannot do anything with this. This is how it will be. This is how my networks are. Try to improve it. So then they focused, like 10, 12 years back. They focused, okay, control plane and management plane. The initial developers of SDN, they had the major problem with control plane. That is where they have the major problem. So what is the thinking? What is the thought process? This is the thought process. Before I give you the thought process, I want you to tell me, what is this?
Router.
Anybody else? What is this? Everybody says router, right? Who told you this is a router? Epic. Oh my God, Deepak is going crazy here. Yeah.
Kalyan, I'm sorry, but can you repeat your question once?
Yeah, what is this I'm asking? If you want, I can try it one more time. What is this?
Means management plane, control plane, and data plane. Correct?
What is this? I mean, I know you're trying to be creative with your answer, but try to keep it simple.
Yeah, actually, each device is in these present scenarios.
This is my question. I mean, why are you complicating it? I'm just asking you, what is this? That's what I'm asking.
Router.
Okay. Right. So, yeah, you wanted to give a better answer. I understand your urge of it, but this is what we think, right? Whenever there is a circle with a cross from CCNA, somebody told us and we were following it. That is the router. This is getting connected to this. What is this? We will think it's a switch. Right? What is this? It's a system. Think so. I'm connecting from here to another box, connecting from here to another box, another, and maybe another, and then another, and I'm going this side. See, this is what I wanted to prove. This is the point which I wanted to convey. The point I want to prove is we have a mental block, right? It's a mental block for us. Now, it's not our problem really. This is how networks work. We simply called it a router. Now let us see what is happening. The packet is coming from the system to this box. Once the packet comes to this box, 5.5 to 6.5, this box gives that packet to a centralized location. We now call it as controller. It gives it to this centralized location, okay? See, I don't know what it is. Like, I don't even know 5.5 going to 6.5. I don't even know that. I don't see that. When a packet comes, I will simply send it to this controller. This is the first flow I am getting. As soon as I'm getting a flow, I will give it to the controller. The controller looks into it and tells me, maybe this is 000, this is 001. Okay? My controller tells me, draw. What? I was expecting it to go in one or the other place, right? That's what you were expecting. No. But the controller said, drop the packet. Okay, anytime this 5.5 is trying to communicate to 6.5 with that flow, I'm going to drop it. Why? Why did the controller say drop? The controller said drop because when it looked into the packet, the port number is 80, but the payload inside that is a torrent. That's why it asked to drop. Oh, so now what is this box acting like? Tell me. Guys, that should be an easy answer. What is this box acting like?
As a gateway.
Okay.
As a
I
brain.
thought it is acting like a firewall now. Right? Acting like a firewall. Now when other flow comes. Now when the other flow comes, when the other flow comes, again, it is sent to the controller. This time the controller sees and says, okay, this packet is going to 6.5, the packet looks legitimate, so I want to send it on serial 0/1. Why do you want to send it on serial 0/1? Because all these devices have registered themselves to the controllers. Anytime any change occurs in any of these devices, they are going to immediately inform the controller about it. So what happened is 1 second before this packet came, this link went down. This router does not even know about it. But the controller is given that information from the device. So the controller knows this link is down, sending the packet in this direction is not going to work, so send it in this direction. That's what I did. Okay, another flow is coming. When another flow is coming, what I say is, I take it to the controller. This time the controller says that links are up, go in both the directions, and I want you to do load balancing of it. And the load balancing I want to do is per packet or per flow. Or I can also instruct, send 2 flows here, 1 flow here. Send 5 flows here, 1 flow here. My decision. I will decide it. Suddenly, this is doing unequal cost load balancing. I hope you are getting the catch of this from the examples I am giving you. See, if I have to get this unequal cost load balancing, I must run a protocol called EAGRP. And if I have to run EAGRP, I must buy a Cisco router. No. If I wanted to have a beautiful deep packet inspection, anomaly tracking, each firewall from different vendor has their own special features. See the irony of it. The same vendor, if you are running a particular version of the iOS or any operating system, the feature will not be supported. But now if you want that feature, you have to upgrade the same box. So the same vendor also, that no guarantee. I have to put a maintenance window. I have to have 2 boxes for redundancy. And then I have to upgrade the box one by one. I want VXLAN. I want fabric path. I want VPC. I want that technology. I want this technology, MPLS labeling. Anything I want to do, I am totally dependent on the operating system of that box. And that operating system is what is telling me what feature is possible, what feature is not possible. The intelligence of the box is in the operating system with all of its processes. Why don't I take it out? Like completely. Even open standards. OSPF I don't want, ISIS I don't want, PGP I don't want, EHRP I don't want, VPC technology I don't want, nothing I want. The whole intelligence goes to the controller now. You, the boxes, you just follow the instructions, that's it. Anytime a flow comes, go contact the controller will tell you what to do and you do accordingly. Advantage. Tomorrow I come up with a beautiful program. It's almost like an application. Should I go to any of these boxes to do that beautiful thing I developed? No. I simply install that on the controller. That's it. My new program works. Do I have a proprietary lock? No. As long as they both can talk the same language, which must be an open standard, then I'm good. I don't need any proprietary lock. When I am getting any flow, the controller is giving instructions to the boxes, right? Which means it is dynamically, depending on the per flow basis, literally, dynamically making configurations to these boxes. Whichever box I want to make config, I can push the configurations to those boxes. So this is the initial idea of SDN. They said, we are going to have control plane and the management plane centralized. Take out all the intelligence from the boxes. Whoever has a better silicon, they will win. That's it. We don't have any proprietary. Over. This is the dream. This is the dream they had. Data plane will be localized, distributed. You can't change that. You don't want to change that. That's how the networks are. That's going to be distributed. Now I gave you some fancy examples here. Okay, so detection of links, unequal cost load balancing, behaving like a firewall. I gave you all these fancy examples. Is there any real-time protocols or anything that are really there right now? Do we have them? And the answer is absolutely yes. And everybody, they are not developing different protocols. Everybody stick to this standard called OpenFlow. Not OpenStack, that's different. This is OpenFlow. Okay, so HP switches supported, certain Cisco switches support them. So everybody is like, oh, okay, excellent idea, brilliant, fantastic. Everybody is like, okay, this is the protocol. And if you see the initial revisions, like upgrades of this protocol, literally every 3 months, 6 months, they had a new version. Okay, pretty new, pretty infant stages right now. So yeah, nowadays it is like every 1 year you are getting an update. So this is improvising. The idea is for the tomorrow, there should be no proprietary lock. It's almost like, I'm not joking, it's almost like you open Play Store or App Store and then you search for your network applications, and somebody would develop an application for traffic engineering. Somebody would develop an application for super cool monitoring. Somebody would develop an application for something else. Okay, so yeah, pay 1,500 rupees per month, install the application. That's it. That's it. That's the idea. No more Cisco big vendor, no more Juniper big vendor. No. Sell applications. That's all. You don't try to sell me the box. You sell the box, and from the box you say there is a feature, and that feature, for that you need to buy another box. Don't lock me there. That is the dream of SDN. And OpenFlow is very much there. That's an example. I mean, today there's no other development. It's just OpenFlow. People are developing that. Do you think Cisco SDN falls under this category? Yes or no? Make a guess. Okay. No, it won't. Okay. So, people, vendors, I mean, they're obviously, it's too scary. It's way too scary. Really, forget about we losing jobs. Cisco will lose that company itself. Like, really, if that happens, if everybody does this. And let me tell you my personal thought on this. Okay, so this is a fantastic thought, a very good idea, and people are developing it. Even Cisco, everybody else is a part of this group. Okay, because they have to be prepared, right? They cannot lose the company, so they have to be prepared. But one of the major problems with this idea, with this protocol logic, is one word: support. It's almost like Linux, right? Very powerful. Linux is super powerful. Nobody can deny that. Okay, everybody agrees to that. It's definitely super powerful. But the question comes, who will support? At least with regards to Linux, somebody like Red Hat came and said, okay, if you are installing my flavor, we will support it. Somebody came and said that. We have to wait. We have to wait and see if somebody can come up and say, okay, you run OpenFlow in your networks, we are there to support you. SLA, 5 nines. We are ready. 99.999, we are ready. If somebody can guarantee that, oh my God, these companies have to really look for alternative businesses. Okay. So, and by the way, if it is Cisco, they already have a plan for the next 20 years, and that's why they have gone into the other industries like IoT. They are doing a good job there. They already started it. So they have their own plans. So the company is thinking ahead of time. Yeah, that's where things can go wrong. Support. Everybody says, yes, we will support OpenFlow, but we don't support the problems that might come with OpenFlow. Okay, so that's the challenge. What Cisco came up with and what Cisco's SDN, not only Cisco's, other big vendor solutions is in the second category. In the second category, what they said is, see, you are depending too much on the controller. What if the controller link goes down? They say, this first set of people say, no problem, we will have cluster of controllers. But then there is a lot of networks here, lot of devices here. I mean, I drew like 5 devices, but they can be literally thousands of devices. So managing all of them will become a problem in the controller. They said, these people said, don't worry, we will have clusters of controllers. This cluster will manage a group of devices. This cluster will manage another group of devices. The clusters can synchronize their database. So they're coming with some solutions. But finally, the other vendor said, no, we are not doing this. What we are doing is, we are going to make the management plane centralized. The control plane and the data plane, this is going to be still distributed. This is still localized. Whether you go for this umbrella or this umbrella, one thing is common. You will have, whether it is this or this, you must have controllers and devices. The devices should know where the controllers are, and the controllers should know who the devices are. They must know each other. How they know each other? Again, depending on the solution, you can manually configure, like all the 200 devices you can configure. You can do it in an automatic fashion also. Okay. Again, there is some solutions called NSO, which you have to do it manually. Okay. And there are certain things like SD access, which you can do manually, but you can also do automatically. Okay. And then we have this thing called WAN automation engine, wherein again, you configure, how do I say, semi-automatically. You will configure the seed devices, 2 devices in the network, and from there they use LLDP and CDP to auto-discover. So they do both at the same time. When it comes to ACI, it is all automated process. So end of the day, the idea is controllers and the devices, they should know each other. So whichever solution. Okay, so once they know each other, what the second umbrella said is, see, we will only give the configuration. Only the configuration will be done from this controller. But the actual intelligence, actual protocols, actual control plane is all running on the boxes only. Which leads to a very important point. Tomorrow I have my ACI fabric or whatever, and I have a controller for that. We will say what that is later. But I have a controller. For some reason, the controller and the ACI fabric lost connection. Will my data flow have any problem? Absolutely not. Because I'm simply pushing the configurations, collecting the information from the devices, and putting that in one single pane of glass. I am not involved in any of the control protocols. I am not at all involved in the data plane. When it comes to the other, the first scenario, anytime the data comes, I go to the controller, and from there that I get the instructions. But whereas here, no, I'm not even getting involved with the data plane. I'm not even getting involved with the control plane itself, first of all. It's all separated. That's what they said. Now, here is the important thing to understand, because this is where I personally got confused. Okay. Only management plane is centralized. Oh, so controller will push the configuration. Oh, okay. But I think I was doing this management plane centralized even today without ACI, without this concept. I am doing it even today, not today, like last 20 years I am doing, using scripts, right? I was writing scripts. We write scripts and we can push the configuration to 100 devices at the same time. I can do that. So what is so special? What is so special about management plane being centralized? In other words, what's the difference between sitting in one place, writing a script and pushing the config to 100 devices versus using a controller to configure? What's the difference? Both look centralized to me. This is the difference. If you run a script, for example, okay, the scripts are ultimately automating the manual process, like literally automating the manual process. Let me explain that. See, if I wanted to run OSPF, okay, if I wanted to run OSPF, I will have to give certain commands. Enable conf-t router OSPF1 network 00000 area 0, for example. This is what I will give inside the script. And in order to execute this, I'll have to telnet or SSH into the devices. So using the script, I will telnet or SSH into the script. Instead of me going one by one, I will go into 100 devices using files and input from the file and all that stuff. That's all scripting stuff. I can do that, and I will give these commands. Like whatever I am supposed to do manually, I would run it in the script so that things will be faster. But I'm not doing anything differently here. Okay, but what's the problem? Here is the problem. This list of commands work only with iOS. If I go with iOS XR, my commands list will be different. The format there, network command will not be there. I'll have to go to the interfaces and give it. There, I don't know how many interfaces will be there. Everything has to be consistent. So I have to write a script for every type of box. Ultimately, what am I doing? Simply enabling OSPF. So within the vendor itself, different boxes have different command styles. Now, if I have to manage multi-vendor, that's too complicated. This is what you did, and even today, if you're running scripts, this is what you were doing. Whatever commands I would have given directly going there, I would run it in a program so that it will do it faster, that's all. With the SDN solution, you will hear this definitely whenever you read any documentation for SDN. Intent-based configuration or policy, whatever, you will see this word intent-based. That is what you will see. And that is the real difference between writing a script versus doing the configuration using controllers. Let me explain this. If you go into the controller, for example, you wanted to run BGP, you wanted to run ISIS. In our case, we want to run COOP. If I want to run, I will have an option like BGP enable. That's it. That's all. I'll just check. There it will ask me autonomous system number. I'll just give the autonomous system number. That's it. I'll give the autonomous system number and I'll just say check. Right. I do not have to give, like in a script I have to give, but here I do not have to give the exact commands to execute. I don't have to do that. That is what is taken care by the controller. Controller looks into the devices, monitors them, what is the type of device, and then accordingly, it is going to give the relevant commands. It is going to create the relevant command list and send those commands to that particular device. I am only giving the intention. I am only giving the intention. Let us take another example. I said, we have these EPGs and all, right? I said, on the leaf 105, if the VLAN 55 comes, it will fall under the EPG number 1. And the EPG is in this bridge domain. This, from the ACI, from the controller, I will configure. I will have to configure, no magic shows. But once I configure this, whenever a packet comes with the frame comes with a VLAN of 55, immediately I will create the SVI for this. For that, I will give the IP address of the bridge domain immediately. Tomorrow, if this device moves to another port, if I configured that port also to have this mapping, automatically I will get that SVI created. My routing is enabled. ISIS is automatically enabled on all the devices. That is what true management, centralized management means. And there is a clear difference between scripting versus using a controller for centralized management. That is what this SDN solution gives me. So with regards to Cisco, they fall under this category. And as I said, there are many SDN solutions they have. One of those SDN solutions happens to be ACI, application-centric infrastructure. And with ACI, what you have as a controller is what we call EPIC. Okay. EPIC controller is what we call. So it is through the EPIC controller you discover all the leaf automatically, and then you discover from the leaf all the spines. You have to do a registration process for that. And once you do the registration, it is going to discover the other spines, and you register them. And once they are registered, you are going to now be the management point. You are going to instruct to run ISIS. You are going to instruct to have an SVI. But the actual ISIS, actual topology tables, it's all in those leaves and the spines. You are not involved with that. Sure, I monitor. So I go to the controller and I can see everything. But I'm not involved in the data plane. Okay. Now, when you want to use this ACI, currently, the only switches that support ACI are 9K switches. Now, when you go to the 9K switches, within that you have two modes of operation. We call it as NXOS mode, and the other one is called ACI mode. Now, again, I don't know how you bought the box. Okay, so when you are purchasing, you say, we want to execute it in ACI, you will be given a separate flavor of the operating system. Okay, if you said no, you are going to get it with NXOS. Okay, anytime you can change it from one mode to another mode, you can do that. Reboot is required, point number one. Point number two, you cannot run in both the modes at the same time. You can't do that. Either ACI mode or NXOS mode. Now, here is the, big thing, like practically, we feel a little weird if we don't know this. Once you decide to be in the ACI mode, okay, you ask it to boot from flash, that ACI version of the operating system, the router boots up, and you cannot configure the boxes directly connected anymore. You can't do that. Over. Once you are in the ACI mode, you can only configure using this EPIC controller. You can go to the privileged mode later once you configure the basic config. You can do monitoring, like I can give the CLI commands to monitor stuff, but I cannot go to the global config. No, gone. Initially, if I did not do the basic config, I can't even log into the boxes. So basically, you are giving either the total control to the controller or not giving at all. There's no partial thing. Okay. So currently, that's the level at which the software hardware restrictions are. I don't think it's going to change anytime. Okay, that's how it's going to be. So keep that in mind. Okay. So I think with this, I would like to draw the line.
But there would be possibility if we want to just go back to the NXOS mode.
You can do it. You can do it. Anytime you can change from one mode to another mode, absolutely no problem. The only thing is you cannot use it both at the same time. So tomorrow I said, okay, this is leaf 125. I don't want to use it in the ACI. No problem. Connect to the console. Go to the setup mode. And then you can erase the entire configuration and you can boot from the NXOS. one more time, you have to reboot from the NXOS and clean slate. No config, nothing. You just take it out, no problems. Anytime you can change it from one mode to another mode. The only challenge is can't use it for both. Same thing, vice versa also. You already have it in the existing setup, you're running it, there is some config. Now you want to put it into the ACI, same drill. Erase all the config, go to the setup mode, boot from the NXOS mode now, and then just connect it to the existing fabric.
Can we use 7K also for ACI?
No, not at this point.
Okay.
7K only recently, like when I say recently, I think 2-3 years now, they started supporting VXLAN itself. Okay. And my prediction, and I'll tell you the logic behind it, inevitably every Cisco house, okay, every Cisco house will use ACI. Like, no two ways. They will use ACI. If not today, tomorrow, day after. The question is not, will they use ACI? The question is, when will they use ACI? That's all. That's how it is going to be, definitely. I'll tell you the reason. The reason is 7Ks are going out of end of life, right? So people are not buying 9K, they are not going to ACI, majorly because of that reason. They already had the investment made, they already took the service, and end of life is there for 2 years, 1 year, whatever. They are all going away. Okay, slowly, a lot of 7Ks have gone end of life. So either they have to extend the service, very some people will do it, and some people, they want to replace the boxes, end of life, so we want to buy a new box. What Cisco is doing, again, this is my take, okay? So what Cisco is doing is 9K silicon cost is less relative to 7K. Okay, they have hardware, silicon is cost less. So generally companies will go for lesser cost, right? And that's a better model, better features. So that's the trick they played. Okay, so now everybody who did not have ACI, they are basically waiting for the 7Ks to go end of life. That's it. So once that is gone, if they have to take a choice, they will go for 9K. And now once you go for 9K, immediately they will come and say, don't use 9K in NXOS, please use it in ACI. They will say that. And it's reasonably right, okay, to move to ACI. So that's the point. So if not today, tomorrow, maybe Cisco is okay with increasing or expanding the service agreement with 7Ks. But that will also expire, right? At one point, it will also expire. So inevitably, the client will change. So because of the price difference, I think 9K they will all take, and next 3 months they will move to ACI. You know, this was happening for the last 7 years. First year actually, when ACI came, the very first year it was very dull. Oh, ACI, GUI interface, network, automation. People were afraid. Okay, people were really very afraid. And this is like 7-8 years back story. So yeah, now it is not like that. There is good knowledge pool now.
And Kalyan, how do you see cloud means from a future perspective? If we compare ACI or cloud means, what would be the future?
See, how do I say? You are looking at two different career options. Okay. You can't do the comparison like that. See, once upon a time, I don't know, maybe you had to take a decision. I'm assuming you had to take a decision because most network guys had to take that decision. Once upon a time, I think when you started your career, you had two choices, right? You can become a network engineer or a system engineer. You go to Microsoft or you can go to Cisco, right? So which one is good, which one is not good? How do you compare them? You can't compare, no? Am I making sense?
Yeah, but actually,
You can't compare. No, I'll come to that. So you can't compare those two things, okay? Now, you are a network engineer. Let it be a private concern or a public concern. Let it be a service industry like HCL, IBM, Wipro, all this stuff. You are the infrastructure owner. Like you are the direct access to the infrastructure. Okay. You are the direct. Let me use this. You are the direct owner of this infrastructure. Now, what is cloud? What is cloud? You will have an ACI fabric. Okay. You will have an ACI fabric. And here, you will have OpenStack. Here you will have OpenStack. And then here, you will have VMware. VM Cloud, they call it. vCloud, they call it. You have vCloud. Okay. These are using ACI, Epic controllers to manage these boxes. And this is OpenStack using x86 regular boxes, and they are installing their own VMs. And then you have this Hyper-V clouds. These are all the different boxes which all is put into what we call cloud. Now, what is happening is this. This is where your questions will come. What is happening is all of these have got APIs, okay? This has got an APIs, this has got APIs, OpenStack has got APIs, Epic controller has APIs. They are all these APIs exposed to, in these multi-technologies, they are all coming into this API cloud. Now, what this guy is doing, right? This is cloud for us. Okay. What this guy is doing, he is giving connections, or he's taking the advantage of these APIs. So from here, you are going to spin up virtual machines, provide resources, provide VLANs, all that these AWS, once you take AWS resources, all that you do is fill up a form, and with that form, you are going to provision these resources. This is what you're going to do. Okay, AWS, Azure, or Google Cloud, all of this. So now, your question is, because this is very hyped and this is very real, this is there. Shall I focus on the cloud or shall I focus on ACI is what you're asking me. Two different things.
Yeah, this is my actually this was my question. Yes,
exactly. Yeah, so because end of the day we don't care about technology, we care about our career, right? So this happens. This is what. So it's almost like asking, do you want me to be a network engineer, stay here, or do you want me to learn this and be here? And let me tell you, within this, there is this front end. Okay, front end, you are seeing this web page, you log in, you can spin up VMs and all that. This administration is one thing, and here they are making connections to the APIs, right? This is what they call AWS programmers, developers they call. You Google AWS, Azure, any cloud. Developers is a separate skill set. Administration is a separate skill set. Okay. Now, my personal talk, my personal suggestion, learn definitely one of this. Trust me, it's very easy. Okay. Yeah, terminology will be different. It looks a little weird, vague. I mean, come on. Initially, enable, conf key, host name, everything was weird to you, right? Router, BGP, number, everything was different. We did not know OSP of process ID can be different or not. Right?
Correct.
We did not. We came from there. And today,
Yes.
We talk like masters. We are, okay, to some extent. Yeah. So, same thing. Learn this. Never give up on this one. I mean, this is the meat. Okay. System administrators are there, right? They are also doing the same. They are not giving up VMware. They are not giving up Linux. They are not giving up Windows. They still, final infrastructure is there. You still have to keep that knowledge and advance it to whatever they are bringing into this cloud. This is a silly part, really. Nothing big. Nothing at all. Okay, so learn this additional skill, definitely useful for you. Okay, because initially in the last 3-4 years there were less number of people here, it looks like a demand, but eventually, freshers are learning cloud today. They are learning how to spin up the VMs and all that. Okay, this is again
everyone is learning cloud.
Yeah. So what they are learning is this one. They are learning this one. Now this is costly. This is tough. This part, integrating the AWS programmatically to other things, creating the APIs. Now this is tough. This requires programming. This requires knowledge on programming. This requires knowledge on networking. This is the tough place. Okay. I don't know. I'm learning it, but not this part. I'm learning programming these stuff independently. But I don't know. It's a very, very lengthy process. Okay. So I don't know if you want to go here. You have to learn Python at least to a good extent, and then you have to play with AWS, the APIs. What is APIs? You have to know a lot of programming stuff. So it's a lot to ask for a 15-20 years network guy. Yeah, so this, tough to do. Tough to do, not impossible, but this is challenging. So, please be a AWS administrator. That's an easy thing to do. Azure administrator. That's literally networking. A lot of designs, etc., will come into play. But these things, for us, that too, we see a lot of complicated networks and all. For us, this looks very easy. No problem. Okay. So please don't leave this, which you have gained for like 15 years or so, for this administration, which you can learn in 15 days. 15 days you can learn. You take a free account, AWS free account, learn all of that in another 30 days. For that, you don't spend too much time. I don't think you should spend too much money also on that. Okay, everybody is offering now. So two different things for you. This will stay. This is never going to change. This is going to evolve, but end of the day, somebody has to take care of these things. Okay. Your next best bet from career perspective, go to product companies That's your next best bet. Okay. And if you want to have a like bindas job, like comfortable, okay. Every time you make a call, every time you get a call, somebody is sitting in the other side, right? In the client side. You can go and join there. Okay. So we all know, right? And I have been teaching Cisco people. I am teaching the so-called clients of Cisco, like direct Cisco clients I am teaching. And then I am teaching service side. Okay. Who is under scrutiny? Who is always under pressure? Come on, you guys can tell me. Here you have the product guy, Cisco. And then there's a client of Cisco. Right. So we go to Alliance, I go to SAP, SAP, I go to big players, I go there. And they have their infrastructure. So Cisco will sell the boxes to these guys and they will give some training to them. That is where I go. Okay. What they say is, okay, training is given, box is sold, my job is done. So 1 year agreement. 1 year they will talk to each other very happily, nice. SLA 4, service, severity number 4, severity number 1, whatever. That's all done. 1 year is over. Now they will say, they will go to the service people, HCL, Wipro, TCS, Infosys, IBM, all the service people. So we are sitting right here. So some manager goes and says, don't worry, Cisco will charge you a lot of money. So we will charge you 10%, 50% of it. We have excellent people who can deal with ACI. So now what are you doing? Anytime a problem comes here, these guys are calling you. And you are under pressure. Like, no, Cisco, if I go there, they would do it in 2 hours. You are doing it in 2.5 hours. And you patch up with the Cisco and then you talk and Cisco will say, you are the problem. These people will torture us. Finally Cisco, yeah, I think, again, you are better people to answer than me. I am making some assumptions from what I got as inputs, okay? So Cisco, they will come and say simply, 5 o'clock, my shift is over. We will talk to you tomorrow. Cut. Right? Tomorrow we will talk to you. So then these guys will say, see, because of you, we gave it to you, and the manager will get an escalation and somebody is giving a me jokes here. Okay, so for you, my opinion, you go there. You apply for a job here. Madhavan is saying exactly the same thing happening. So you go there. This is the best bet for you. Okay. Only challenge here is limited offers. Okay. You don't get like mass offers and all. Okay. How many people do you think will sit here? Right? How many people will sit? Really? I have seen at least tens of such clients. Like 10 people, like 15 people. That's all. They are the owners of storage. They are the owners of firewalls. They are the owners of like everything. Of course, they will be the owners of everything because what they have to do is patch the call, right? They have to just make a call to get this problem solved. They should have enough knowledge to understand what you are saying so that they can ask questions as if they are smart, right? I hope you understand what I'm saying. No, a lot of people have this anger.
No, you are right because there we cannot grow up much as we are just growing here in services.
Yes. Okay, that's why I said if you want to have a bindas life, okay, that's no problem. I don't care technology and all. I will sit and make calls and whenever I have a problem, I'll just ask somebody. So if I have like that, okay, no problem. Okay, target that. But as I said, people don't let go these places, right? They are comfortable. They almost, every place I go, they're almost like a family. Like they don't let go anything. Okay, so it's very tough unless they had some really personal things to handle and they have to get out of the place. Otherwise, it's a very comfortable place. And these are big companies, so they have to inevitably give certain appraisal, certain things they have to do. So salary wise also they are reasonably good. Okay. The next best option is go here. Okay. You can love technology, you can do very good stuff with this. At the same time, you are kind of over the top, right? So if Cisco says it will take 5 days, this guy will keep quiet. But if you say 5 days, not 5 days, 5 hours, they will start escalating. Okay. So the second best bet is go here. Here you get good chances. But comparatively, very good chances. Compared to this place, very good. But if you can keep watching for a position here, oh, that's it. Okay, so that would be my management idea for your careers. But technically speaking, yeah, you learn ACI. You definitely learn ACI. You definitely learn SD-WAN. ACI and SD-WAN. Okay. SD access is very popular, but it will take time. It will take a good amount of time. Okay. So yeah, ACI, SD-WAN, keep them your immediate priorities, and then maybe SD access. So with that, you just apply and see how the results are. ACI is also getting competitive, guys. Okay. 3 years back, if you just put ACI in your resume, 3-4 years back, just ACI in the resume somewhere, you will get calls. Now, yeah, you may get calls, but it's a little competitive. SD-WAN is becoming even more famous. It's very new. Like deployments are very new, and they will happen in the next 4 or 5 years. SD-WAN will grow. People are waiting for this pandemic effect to go away. Once it is gone, SD-WAN will kick in very rapidly.
Yeah, that is what I felt like saying. Means I have observed due to COVID, everyone is migrating to the cloud. Due to COVID, actually, they didn't want to means totally migrate on the to the cloud, but they have to due to COVID-19. So, will there any chances then if we get COVID vaccine? So thereafter, once it is gone, so will there any chances that they will come back to these ACI, SD-WAN or?
Yeah. Definitely. See, understand, even if the environment is, even some clients going into the cloud, still SD-WAN will pretty much be there. SD-WAN is the WAN connectivity, right? So whatever is there on the other side, it could be a cloud, it could be a data center, it could be a public or a private data center, doesn't matter. My SD-WAN is still an independent piece, and I need that to be improved. So that will stay always, okay? And even the ACI deployments, as I said, like 20 minutes back, inevitably they will move. Inevitably the 7Ks will become 9Ks. Inevitably ACI will be there. Yeah, so that is also going to stay back. And why I was highlighting is because just before the pandemic, there was so much of SD-WAN need, like from a training perspective, people asking about it, clients wherever we go, they were asking about it. And suddenly then pandemic started. So all of those, they will reschedule their migration strategies after this is all done. Okay.
Kalyan, if I talk about security, means will they get the proper security, data security in the cloud?
My take, no matter what happens, no matter how much guarantee we give, financial organizations won't get into the cloud. They won't. They will rather build their own cloud. They won't. Okay. AWS gives you 200% guarantees. Other clouds will give you 300% guarantees. No, they won't. Too risky. Do you think any social marketing websites, will they go to the cloud? No. They won't go to the cloud. They will build their own cloud. Private cloud, given access to the public, but it is their own property. They don't go to AWS. They don't go to Azure. No. So it won't go away. Security will always continue to be a threat, no matter what guarantee people give. All right. Okay, guys. So with this, we will wind up in another 10